So yesterday we have done a lot of problem on a cube plus b cube plus c cube minus 3abc term. Okay. So today we will just revise all our previous concepts. Then we will move on to our next concept. Okay. So let's start. So this is a very basic question. We all can try this one. So what this question is saying, if x square plus kx plus 6 is equal to this term, we have to find the value of k. Okay, we have just to find the value of k. So let's do this. So x square plus kx plus 6. Open this bracket. You will get x square plus 5x plus 6. By comparison, we can say k equal to how much? 5. So it was a very easy question. No problem in this. Correct? Okay, let's move on to next one. This was just a warm-up question for us. Solve this one. Now here it's given a plus b plus c is equal to 0. This implies that a cube plus b cube plus c cube is equal to 3abc. I can write this thing as 3 cube plus 5 cube plus minus 8 whole cube. Now since a plus b plus c was 0, so it will be equal to 3abc. Correct? 40 into 9 is 360. So this answer will be minus of 360. Or we could have find a cube plus b cube plus c cube, all the values here. Okay. So in both the scenarios, answer will come same. So here we are just using the property of a plus b plus c is 0, then a cube plus b cube plus c cube is equal to 3abc. Correct? Yeah. Let's move on to next one. Again, a easy question. We can try this one. Yeah, there is a minus. So we can write a plus b. Okay. So one is having confusion here. We can write this thing as 3 plus 5 plus of minus 8. We can write minus 8 like this. Correct? So it became a plus b plus c, and c is minus 8. Okay, try this one. Answer is 2. Okay. What we will do? It's given that x plus y is equal to 3. We will do squaring both sides. Don't write it as x square plus y square equal to 3 square. That's not squaring both sides. It will be x plus y whole square equal to 3 square. So x square plus y square plus 2xy equal to 9. And x square plus y square is given as 5. So 5 plus 2xy equal to 9. So 2xy equal to 4. So we get xy equal to 2. Xy equal to 2. Yeah. Can we move on to next one? Okay, Karthik, I will send all the notes. No problem. Okay. It's kind of linear equation in two variables. We can solve it. There are two variables x and y in this. So it's given that 3x minus 2y equal to 11. 3x minus 2y equal to 11 and xy is equal to 12. So we have to solve these two. So 3x minus 2, y can be written as 12 by x. See from here, can I write y is equal to 12 by x? Correct? Now we have to just solve this. So it will become 3x square, take LCM, 3x square minus 24 equal to 11x. So 3x square minus 11x minus 24 equal to 0. Is it correct? 3 into 24 is 72. 3 into 24 is 72. So, can we find its root? Tell me. Can we find its root? This is not a good approach. Okay. This is not a good approach. I'm just asking. I'm telling you the first instinct which comes in our mind is to substitute the value of y in the first equation. Okay. Oh, okay. So splitting the middle term, we say 3 into 24 is 72. So we calculate by 16 minus 5. 16 minus 5 is 80. Okay. So 15 into 4 is 60. So its answer will come as irrational roots. Answer will come as irrational root. So this is not a good approach. You will get, yeah, discriminant. When you find its discriminant, it will become irrational. Let me show you. X equal to minus b plus minus under root b square minus 4ac upon 2a. When you will solve this discriminant, it will be very, not a perfect square. Okay? It will not be a perfect square. It will not be a negative, but it will not be a perfect square. Okay? Even if you take the value of x, it will be a very odd type of equation. Odd means roots are coming. We don't like roots. Okay? So we'll apply a different approach. So this approach we didn't like. Okay? So this approach we didn't like. So let's move on to the next approach. See here, it's given 27x cube minus 8y cube. Can I write this thing as 3x whole cube minus 2y whole cube? 3x whole cube minus 2y whole cube, which is what? A cube minus b cube. Which is what? A cube minus b cube. I will use this formula. A minus b into a square minus a plus ab plus b square, or I can use this formula a cube minus b cube, that is equal to a minus b whole cube plus 3ab into a minus b. Which formula to use? First one or second one? Tell me this thing. Which formula to use? First one or second one? Some people are saying first, second. Okay. Apur is saying second. So second formula is a better one because we don't know a square and b square. We don't know a square and b square. So we will use second formula because we know the difference and we know the product. So I will use the second formula here. Okay. So it will be equal to a minus b plus 3a into b into a minus b. A minus b. Correct? So, after solving all these things, what we will get? Let's solve it. So, this will be 3x minus 2y. I can bring 3 and 2 outside. So 3, 3, 9, 9 to 18. 18xy into 3x minus 2y. Correct? Now, what is the value of 3x minus 2y? Yeah, it will be cube. What is the value of 3x minus 2y? That is given as 11. So 11 cube plus 18 into xy is given as 12 into 11. Okay. So we have to find the value of this thing. Correct? So what is 11 cube? What is 11 cube? 11 square is what? 121. 11 cube is 1331. Okay, so we got this as 1331. Now we have to multiply this thing. What is 18 into 12? 18 into 12 is 216. Okay, 216 is there. Then we have to multiply it by 11. 2160 plus 216. That is 2376. That is 2376. So 2376, 2376. Add these two. 1 plus 6, 7, 10, 7, 3. So answer is 3707. Okay. So it was a good question only because we have to see that we can't solve it by solving linear equation in two variable. That's substitution method. And again, when it's coming to this part, a cube minus b cube, we have to use this second formula because here difference and product is already given. Understood, everyone? I think so. All of you have said answer A. Okay. So let's move on to our next question. Okay, let's try this one. Kaneki is saying why you always start your class on time. Always be on time, Kaneki. Test is on Wednesday. I have told it. You can see yesterday's lecture. It became 3x square. Abhinav is seeing something else. 3x never became 3x square. It became 27x cube became 3x whole cube. Wednesday is my lucky day. That's why we have kept exam on Wednesday, Sanjana. Okay. So we have to find the value of 1 upon x, 1 upon y and 1 upon z. Okay. So see here. See here. I can write this thing as 4x minus 3 upon x is given. Then 4y minus 3 upon y is given. Then 4z minus 3 upon z is given. I will split it into two terms. 4x upon x minus 3 upon x. 4y upon y minus 3 upon y. Then 4z upon z minus 3 upon z. So here x got cancelled, y got cancelled, z and z got cancelled. Okay. Now what we will do here? See, it became 4 minus 3 by x plus 4 minus 3 by y plus 4 minus 3 by z. So 4 plus 4 plus 4 will become 12. If I will take minus common, it will be minus 3 by x plus 3 by y plus 3 by z. Okay. And this thing is given as 0. This thing is given as 0. Correct? When I will take 3 common, it will be 12 equal to 3 times 1 by x plus 1 by y plus 1 by z. Clear? Yes. When 3 is cancelled by 12, it will become 4. Okay. So why we have split it in this question is because we need the value of 1 by x, 1 by y and 1 by z, which we are seeing that we can get by splitting all the terms here. Understood? Any doubt in this? Any doubt in this question? Or is it clear? Okay. Abhinav is saying where 3x become 3x square. So nowhere we have written 3x square. Okay, Abhinav? Nowhere we have written 3x square. Is it? Please see Abhinav. Other side. Okay, okay. Abhinav is stuck here. See, 3x into x, when we will take LCM, what will happen? 3x into x will become 3x square. It's a bit kind of LCM thing only. Okay. Yeah. Okay. Now see here, somebody is asking it was minus here. I have taken this term to the RHS. So this minus sign will become plus sign. Okay. Johit? Okay. Okay, okay, okay. So again, no class on Sunday and test is on next Wednesday only, coming Wednesday only. No test tomorrow. Okay. Very good, Karthik. You got a wrong answer. Let's move on to next one. Okay. We have to solve A plus B plus C is given as 0. So we have already done this kind of LCM. Yes or no? We have already done this kind of LCM. So what we have done? Take LCM of this thing. So it's given A square upon BC plus B square upon CA plus C square upon AB. So what is LCM of this thing? What is LCM of these three? BC, CA and AB. What is the LCM? ABC. Very good. Very good. LCM will be equal to ABC. So LCM is ABC. So this will become A cube because only BC was here. So A will be multiplied. Here B is missing. So B is multiplied. Here C is missing. So C is multiplied. Now A plus B plus C is given as 0. So we all know when A plus B plus C is 0. So A cube plus B cube plus C cube will become 3ABC. Now ABC got cancelled. So our answer is 3. By using the property, it's becoming very easy. Only LCM part we have to see properly. Because 3x minus 2y is given as 11, Jonith, in the last question. 3x minus 2y was already given as 11. That's why I have taken this thing as 11 cube here. Okay? Okay. Okay. Yes, sir. See, from the previous class, I have repeated this formula. Like say, we have done many questions on this. If somebody is not understanding this, he is not getting the point that whenever a plus b plus c is 0, then a cube plus b cube plus c cube will be equal to 3abc. Okay. So always remember this thing. Whenever a plus b plus c is 0, then a cube plus b cube plus c cube is equal to 3abc. Okay. Let's solve this one. Anybody got the answer? Option A. Okay. Okay, let's solve this. So see here. Here we have written A plus B, B plus C, C plus A. So we will use this equation. A plus B plus C is given 0. So we can find three things. A plus B equal to minus C, B plus C equal to minus A and C plus A equal to minus B. We will just put these value here. So I will get 1 by A cube plus 1 by B cube plus 1 by C cube. Now A plus B can written as minus C, B plus C can be written as minus A and C plus A can be written as minus B. Correct? So 1 upon A cube plus 1 upon B cube plus 1 upon C cube minus 1 upon C cube minus 1 upon A cube minus 1 upon B cube. See, everything is getting cancelled. So our answer is 0. Yeah, very good. This was a bit tricky question because There was no formula being used, only substitution was being used here. Can we move further? Yes. Okay. Let's do one more problem. We have not done any problem on this formula, I think so. So let's do it. A plus B plus C whole square. Which formula will be used here is A plus B plus C whole square. That is A square plus B square plus C square. 2AB, BC, CA. This formula will be used here. Sorry. Okay. So I think everybody has written the question. So A plus B plus C is given as 2. So what I will do? I will square both sides. I will do squaring both sides. So A plus B plus C whole square will be equal to 2 square. Correct? So opening this, we will get A square plus B square plus C square plus 2AB BC plus CA. That is equal to 4. And it is already given as 1. So A square plus B square plus C square plus 2 into 1 equal to 4. I will take 2 this side. So I will get A square plus B square plus C square equal to 2. Correct? A square plus B square plus C square equal to 2. Okay. Now we have to find the value of this term. So A plus B whole square plus B plus C whole square plus C plus A whole square. Correct? Open this thing. So I will get A square plus B square plus 2AB plus B square plus C square plus 2BC plus C square plus A square plus 2AC. So see here, A square plus A square will become 2A square. B square and B square will become 2B square. C square and C square will become 2C square. 2AB, BC and CA. I will take 2 common. So A square plus B square plus C square plus AB plus BC plus CA. Now we know the value of A square plus B square plus C square, that is 2, and AB plus BC plus C is equal to 1. So for this I will write a 2 and for this I will write a 1. So our answer will be 6. So our answer will be 6. Understood? Okay. Now square replaced by AB plus BC. Okay. It's already given in the question. What's your name? Matru. Okay, Matru. AB plus BC plus CA will be equal to 1. It's given. Okay, so let's move on to next part. When everybody wants, they can take a screenshot. Okay, I will wait 1 minute. It's a big question. Please write it. Hello, sir. I am from ECIL batch. You, sir, please tell. I what to tell? Nilesh. Yeah, Sharan Tej. Answer is B. 6. If you are done, please write yes. Okay, 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 okay. So I will discuss how to become topper and how to become everything at end of today's class. Okay. It will be an interactive session of how to study and what things to keep in mind. Let's move on to next one. I think so. We have to study a topic first. Okay. Yesterday I told you that we will study today remainder theorem, factor theorem, or roots and zeros of a polynomial. So we will start with that. So what is first? Tell me what are roots or zeros? What are roots or zeros of a polynomial? Roots or zeros of a polynomial. Anybody? The value at which the polynomial becomes 0. Very good. The value at which a polynomial becomes 0. It can be a function of x, it can be a function of t or anything. The value for which a polynomial becomes 0 are known as roots. Correct. So we all know what are roots. No problem in that. From there we come to remainder theorem. Remainder theorem. I will not tell you any hi-fi things here. I will just try to explain you in a very basic manner. Yeah, very good. Charit, correct. The value of x or whatever variable is given there, when we put that in the polynomial and it becomes 0, is known as 0 or root of a polynomial. Correct. Yeah, Giri, correct. Now remainder theorem. See, I will just start with a very basic thing. We all know this sign, division sign. Let's say 7 is divided by 2. So I will get question as 3 and remainder as 1. Am I correct? I will get question as 3 and remainder as 1. So can I write 7 equal to 2 into 3 plus 1? Can I write 7 equal to 2 into 3 plus 1? Okay, okay. So I'm just changing this to this format. Let's say when fx when fx is divided by gx, when fx is divided by gx, quotient is q and remainder is r. Quotient is q and remainder is r. Yeah, it's called Euclid's division theorem or Euclid's division lemma. Okay. So fx will be equal to gx into quotient. It will be also in x and it will be also in x. All will be polynomials. So fx is equal to gx into quotient plus remainder. Okay. So dividend is equal to divisor into quotient plus remainder. In simple language, if you want to say this, is dividend is equal to divisor into quotient plus remainder. Please write this thing. Dividend is equal to divisor into quotient plus remainder. Now, now we want the remainder. Now we just want remainder. Okay. So what I will do, everybody has written this thing? Okay. Okay. So we just want this remainder thing. Okay. So let's take in one more example. Let's take one more example. Let's take x square minus 5x plus 6 is divided by x minus 2. X square minus 5x plus 6 is divided by x minus 2. We all know we can divide this by long division method. Okay. So when we are dividing this by x minus 2, we will get some quotient and we will get some remainder. We will get some quotient and we will get some remainder. We don't know what is the remainder. Okay. So I will write this thing as what? I will write this thing as x square minus 5x plus 6 dividend is equal to divisor into quotient plus remainder. Correct? Dividend is equal to divisor into quotient plus remainder. Okay. Now we only want R here. Listen carefully. We only want R here. We don't want quotient. Okay. So how to remove quotient? So how to remove quotient here? Quotient means this Q part. We have to remove this thing. Or we can remove this whole term. This whole term can be removed by putting some value of x. Very good. So we will put x as 2 because whenever we put x as 2, this term will become 0. Am I correct? Put x as 2. So this will become 2 square minus 10 plus 6, 2 minus 2 into quotient plus remainder. Now this thing became 0. So directly we will get what? Remainder. That is 4 minus 10 plus 6, which is also 0. So we got remainder as 0. Understood? Very good, Mahindra. He studied in his class 5th. Very good. But I think so in class 5th there are no polynomial also. Uh, So I have taken a very basic example. Okay. We can write the definition also. We can write the definition also in this. No, it's not the only factor. It's one of the factor. Okay. It's not the only factor. More factors can be there. Like x minus 3 will be another factor in this. Okay. So I will write the definition if if fx if fx is divided by if fx is divided by x minus a, then remainder is f of a. Put this thing equal to 0, you will get x equal to a, then the remainder is f of a. Yeah, x minus 2 is a factor of polynomial. Correct. But it is not the only factor. So, am I clear? What is the remainder theorem? If fx is divided by x minus a, then x equal to a, put x equal to a there, then f of a will be the remainder. Yeah, I can explain x equal to. So, see here, no problem. You are asking good doubts only here. That this is the polynomial. So, this can be written as dividend can be written as divisor into quotient plus remainder. So, dividend is equal to divisor into quotient plus remainder. We don't require this term. So, we will make, if we don't require any term, we will put it to 0. But randomly we can't put it to 0. So we will substitute some value of x. If I will put x equal to 2 here, 2 minus 2 will become 0. So we are left with only remainder here. Okay, that's why we have put it x equal to 2 there. Understood, Shidich? Okay. Okay. So I will just go through one, two more basic questions. Okay. Let's move on to next one. Please write this if you have already written, I think so. Everybody has written this. Please write yes. We will move forward. Very good. Yes. So, yeah. So, let's do one problem. Then we will understand more. X equal to 2 and x equal to 0 are two roots of the polynomial. These are the roots of the polynomial. As you have already told me, roots means when we will put this value, the polynomial will become 0. Correct? Polynomial will become 0. So, f of 2 will be equal to 0 and f of 0 will be also equal to 0. Correct? Okay. So f of 2 means at the place of x I will write 2. So 2 into 2 cube minus 5 into 2 square plus a into 2 plus b. Correct? So what this will become? I will later write this. So what this will become? 0 equal to 16 minus 20 plus 2a plus b. So we got 2a plus b equal to 4. We got 2a plus b equal to 4. Now f of 0 equal to 0. So 0 minus 0 plus 0 plus b equal to 0. So we got b as 0. Put it here. So 2a equal to 4. We got a as 2. A as 2 and b as 0. Understood everyone? If they are given as roots of the polynomial means when we put the value there, okay? See here, again I will explain. X equal to 2 is root, so I will put x equal to 2 here. So I have put an x equal to 2 here, and this is equal to 0. So 0 equal to, we got this equation. This can be written as equation number 1. And x is equal to 0 is also a root. So put x equal to 0. So this will become 0, this will become 0, this will become 0. So b equal to 0 we directly got from there. Okay? Okay. So take a screenshot. Some students were saying, okay, Jagati, it's okay. Yeah, nice. Raghucharan, you understood now? Yeah, there is Nilesh. You can go to Resonance e-learning channel. YouTube channel is there. There you can go through all the previous lectures also, and you can make notes from that. If somebody is asking about notes, like somebody shared notes right now also. I think so. His name was Jatin. Jatin, I think so. So Jatin, you can send all the previous class notes if you are having them. Yeah. Yeah, it will be uploaded, Vamshi. No problem in that. Okay. Syllabus we will tell on Monday. Syllabus I will tell you on Monday. Thank you, sorry, Jitesh, not Jatin. Thank you, Jitesh. If anybody wants to download, they can download. Okay. Let's move on to next one. Again, some good questions we are doing right now. This is based on remainder theorem. So it's saying that if a polynomial this and this, these are two polynomials here, and they are divided by x minus 4. So remainders are R1 and R2. Remainders are R1 and R2. Okay. So how to get remainder? We have already known. If a polynomial is divided by x minus a, we will put x equal to a in that and we will get the remainder. Correct? So we are dividing it by x minus 4. So we are dividing it by x minus 4. So dividing by x minus 4 equal to 0 means we have to put x equal to 4. We have to just put x equal to 4. Correct? We have to just put x equal to 4 here. So put x equal to 4. So R1 will be equal to a times 4 cube plus 3 into 4 square minus 3. So R1 will be equal to 64a. 16 into 3 is 48 minus 3 is 45. So we got R1. Now we will solve for R2. So R2 will be equal to 2 into 4 cube minus 5 into 4 plus a, that is 128 minus 20 plus a, that is equal to 108 plus a. This is equal to R2. We got R1, we got R2. Now we have to find the value of A if 2R1 minus R2 equal to 0. 2R1 minus R2 is equal to 0. So we will use this relation 2R1 minus R2 equal to 0. Put R1 and R2 here. Okay. So R1 is what? 64A plus 45 and R2 is given as 108 plus A equal to 0. Correct? So open the brackets. 2 into 64 is 128A plus 90 minus 108 minus A equal to 0. So 128 minus A is 127A minus 18 equal to 0. So A is equal to 18 upon 127. Is it correct or wrong? 18 upon 127. We are getting the answer. Yeah, yeah, Seema, I failed to send, I know. Somebody please send the notes to Seema. Shima. Okay. 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 So it's a very clear-cut question of remainder theorem in which we have to just put the value of x minus 4 is the given as factor, or when divided by x minus 4 we are given as, it's not given as factor, sorry. We have to divide it by x minus 4. So we'll put x equal to 4 for finding the remainder. Okay. Thank you, Abhinav. Abhinav has shared the PPT schema. You can download it. Okay. Sasri, you can download it here. Yeah, Kruti, download it. Na? It's already shared in chat box right now. Yeah. Thank you, Abhinav. Okay. So let's move. Oh. Can you move on to next one? Hare already shared. See, message at 8:42. I can see that message. Okay, okay, okay. Got it, got it. Okay, you all can't see others chat. Okay, okay, okay. Got it, got it, got it. So I will share it. Don't worry, don't worry, don't worry. 9 a.m. just after the class, I will send it. Okay. I was not knowing that. Okay. It from my side was showing everyone. We have class on Sunday. Dinesh is asking. No, no class on Sunday. Take a rest for one day. So, see, if you are saying please share the notes, should I stop the class and share the notes first? Okay. Or you can go to just YouTube channel, write all the notes there. Na? Obviously, it's a very easy thing. If you are not making notes in class, go to YouTube channel, write the notes. It's not a big task. Take screenshot from there also. Don't worry for notes. Okay. No exam today. So let's learn a new concept. Okay. Okay. Resonance e-learning. Resonance e-learning is the channel name. Okay. Yeah. So see, factors. If fx is a polynomial, if fx is a polynomial having alpha, beta, gamma as factors, is cubic polynomial, we can say, is cubic polynomial. Oh, sorry. So sorry, it got muted. Yeah, I will just see this. I will again write this. No problem. So what I was saying here is, if fx is a, let's say, quadratic polynomial with with alpha comma beta as roots, alpha comma beta as roots. Okay. Then, then, then fx can be written as, then fx will be written as a times x minus alpha into x minus beta. Now see, what I have done here is, I will explain it step by step. This is known as, leading coefficient. Leading coefficient. This means coefficient of x square. In this question, it means coefficient of x square. Why x square? Because x square is the highest degree. X square is the highest degree. Or if you want, for every question, coefficient of highest highest degree. Coefficient of highest degree. Now, alpha beta were roots. Alpha beta were roots. So these will become factors. X minus alpha and x minus beta are factors. If alpha beta were roots, x minus alpha into x minus beta will become factors. Now let's write this for cubic. Let's write this for cubic. If fx is cubic polynomial, cubic polynomial with alpha comma beta comma gamma. So a bit power cut was there. Okay, so that UPS got tripped. No problem. Am I audible now? Yeah, yeah. Okay, okay, okay. So I think so quadratic was clear to everyone. Quadratic was clear to everyone. So a times x minus alpha into x minus beta. Okay. Now for the cubic, I was saying it is three roots. It's having three roots: alpha, beta, and gamma. So it will become a times x minus alpha, x minus beta into x minus gamma. Yeah, it's a kind of formula. Jitesh, it's a kind of formula only. Let's say it's a biquadratic. It's a biquadratic. So what will happen? How many roots it will have? Four roots: alpha, beta, gamma, delta. So a times x minus alpha, x minus beta, x minus gamma, x minus delta. So it will have how many roots? Four roots. Correct? So see, now note. A note point is here. Whenever it's given monic polynomial, monic polynomial, this implies that leading leading coefficient is equal to 1. This will mean that leading coefficient is equal to 1. Whenever it's given that monic polynomial, in any of the questions it's written the word monic, it means that leading coefficient is equal to 1. So this will be equal to 1. Okay, everybody understood this thing, or anyone is having problem? Please tell. Yeah, Prajwal, please ask what's your doubt here. Until then, everyone write. Yeah, please ask your doubt. Okay, let's do one problem. Let's do one problem, then you will understand. Let's do one problem, then we will understand. Okay, let's take a problem. So it's given that the polynomial fx has given us root 1, 3, 5 and 7. It's a biquadratic polynomial, so it is having 4 roots and it should have 4 roots. Okay, and this is monic polynomial. It's not written. But you can see that coefficient of x to the power 4 is 1. Coefficient of x to the power 4 is 1. Okay. So it's a monic polynomial. Yeah, I will just show the before slide. Yeah, please take a screenshot or write. Take 10 more seconds. Okay. So it's a monic polynomial. So I can say that fx is having how many roots? It's having 4 roots. And what are its 1, 3, 5, 7? So I can write fx as 1 into x minus 1, x minus 3, x minus 5 into x minus 7. Correct or not? At the place of A, I have written 1 because coefficient of highest degree was 1. Okay, correct. So let's open this. Let's open this part by part. Let's open by two parts. Multiply these two. You will get x square minus 4x plus 3. Multiply these two. X square minus 12x plus 35. Correct? Now solve this. So x square into x square is x to the power 4 minus 12x cube plus 35 x square. See, 3 into 3, total 9 terms will come. Okay? Total 9 terms will come here. Correct? So multiply these two. Minus 4x cube plus 48x square minus 140x. Now 3x square, 3 into minus 12x minus 36x, 3 into 35 is 105. Correct? So we had x to the power 4, x cube is here, okay, only two place. So minus 16x cube, x square is here, 35 plus 48 is 78, 83, 83 and 84x. Now we have minus 140x minus 36x minus 176x plus 105. Now compare with the given question. Now compare with the given question. So our given question was saying that a value is what? A value is what? Coefficient of x cube. So we got A as minus 16. B is coefficient of x square. Here it will be x square. So B is equal to 84. C is equal to minus 176. And D is equal to 105. 105. Yeah. Understood? Okay. Just open the brackets, you will form a biquadratic there, and from there you can see and compare each and every coefficients of the terms. Okay, so I will just take your doubts now. I will take your doubts about the preparation, how it's going, how you are feeling. Okay, just tell me. It is 86 x square you are saying. Okay, so 35 plus 73. Yeah, it's 86. Correct. It will be 86 here. So it will be 86 here also. So 35x square plus 48, 73. 73 plus 3 is 80. 83 plus 3 is 86. Correct. Okay, Anish. Yeah, just multiply the terms. Open the two brackets. Okay, so any doubt about the preparation? Any doubt about the preparation? Resonance e-learning is the channel name. You can get everything there. Yeah, question is over, Nilesh. 12x cube, 48 for 16x cube. I think so. It's correct only now. 84 was 86. That was a small mistake there. What is the difference between x minus a and 2? No, there is no difference. Harsh Vardhan, it's same. Havish Vardhan. Okay. Yeah, yeah. It totally linked to JE Advanced also. How many subscribers? You can see in the channel how many subscribers there. Obviously, in app thing, you have to ask your respective campus only. Here. I don't have information about that. Jagati, today's work is done. I am just taking questions. Yeah, might be correct. Nearly that only. What preparation, sir? Tomorrow is JE Advanced to, yeah, tomorrow is JE Advanced to 26. Your super seniors will be giving that exam. Okay. So after 2 years, you will be on their place. How to become billionaire? Sheikh Arshad is asking, and he is written billionaire spelling wrong. So first, we have to start by learning the spelling. Then we can become surely. So random questions we are asking. Okay. Again, who is asking? Varun is asking millionaire. Again, he is written the spelling wrong. Yeah, yeah, Naman. Yeah, I like movies, Kruti. Okay, so tomorrow is holiday for you all. Sunday is holiday. Monday we will be meeting again, and that Monday we will be telling you the syllabus also. Okay, then let's meet on Monday now. Notes PDF. Yeah, today PDF I will just share after the class. Just wait for 2 minutes. It will be shared. Exams are hard only. It's not easy, but it requires a good level of preparation. Okay. Bye everyone.
Hello everyone, this is Zakir Hussain, Physics faculty at Resonance, and let's get started with the today's lecture, which is the third lecture for the kinematics. And last time, let's do a bit of a revision first. Last time we were talking about distance and displacement, vector and scalar. We did some questions, we learned some things. So just a small review, kind of like revision. Oh, thank you about that, Charan. I think it's written. Yes. If I butcher your name, sorry, okay? Thank you, good morning. So let's get started. First, bit of a revision here. So, what we did last time is distance and displacement, as a hidden thing, like extra stuff you can call it, scalar and vector. Wait a moment. Now, what we learn, I'm just going to quickly revise this thing. Distance, always positive. Displacement, positive, negative, zero. Distance is more or less greater than displacement. And what else we learn? It's a directed distance, but that is fine. Now for the scalar and vector, we learn you already know it has magnitude. This thing has magnitude and direction. However, there are some exception to the scalar quantities. For example, we have something called current, which you suggested, by the way, pressure, and I'm still thankful for that. These are scalar, but they do have a direction. Okay, they just don't kind of like change their direction all by themselves. Oh, you're saying that you cannot hear it. Truth, something. Okay. Is it like, am I audible right now? Am I audible? Yes. Okay. Okay. Looks like other people can hear it. So probably there is something from your end. Please check. All right, thank you for this. The voice is a little low. Hmm. So how about now? Is it fine? Okay, I guess. So once again, we saw scalar, in which there are some exceptions like current and pressure, and vectors were simple like velocity is a vector, torque is a vector. You are very curious about the torque, and we literally did a research paper over this thing. And force is a vector, and so and so. So that's what we did last time, along with the introduction of introduction. We need light color. Yes. Introduction of speed and velocity. And we saw it's similar to what we have for distance. Like first point is pretty obvious. It's always positive. Meanwhile, this could be positive, negative, or zero. This thing has only magnitude, meaning you're gonna get a number like 72 kilometer per hour or let's say 10 meter per second. However, this comes with magnitude and direction. Now, direction may not be said directly, like most of the time it would be given something like 10 meter per second in northeast direction. So when it says that, it's telling that thing, like a direction stuff. However, sometimes they just mention plus 10 or minus 10, which tells that these are left hand side and right hand side. This is right hand side, that is left hand side. Okay, so that's what we did for the introduction. Now, somebody is saying speed can also be. You know what? We will do a question here, small question. I want to check did we really get the introduction of speed and velocity or not? And I'm gonna check something in the comment box. There is some question. Wait for it. Um, okay, so this is the question. Speed about the speed and velocity. Okay. Somebody is also asking, can we have the PPT for the CBC physics? I believe it's going to be shared to you from the backend team. Okay, okay. Yes, displacement can be negative. Yes, good, Apurv. Now, the question I want to ask is just to check whether introduction is fine or not, is this. Tell me which statement is correct. Velocity can be zero without having speed zero. Or should I say in simple terms, what I'm writing is velocity can be zero when speed is non-zero. Okay, you just need to tell which one is going to be correct. That's the first statement. And the second statement is quite simple. I just need to copy this thing and right here, I'm gonna place it. Then I'm gonna take this over here and I'm gonna take that over there. And there we go. That's the statement second. So what do you think, guys? Which statement is correct and which statement is wrong? Oh, you know what? Let's do one more thing. If you already got the answer, which many of you do, can you write an example for each one of them? Like anything, like an example. And you know what? Since many of you are giving the answer, why hold it the answer? Let's give the answer. The answer is this one is correct, 101%. An example is very simple. Circular motion. circular motion. In this, the total displacement would be zero, so average velocity is zero, and the speed will not be zero. It is still moving. Second statement, no, cannot. The thing is, speed is magnitude. It is literally the number in the velocity. So speed getting zero directly means velocity is zero. Done. Is that fine? Understood? Okay. Thank you. And by the way, don't type 11 because there is no option 11 or statement 11. Thank you. Centripetal force, that is also correct, Varun. All right. So now let's move on to today's target. Last time I was also introducing that the speed or velocity comes in two types. One is called average speed or velocity. Another one is called instantaneous or instant speed and velocity. By the way, have you ever seen this in your vehicle? Something like that. I'm gonna try my best to make it. It will take just a moment. Something like this, which is present in every vehicle. Do you know the name of this thing? It has a red needle and it shows kind of like the reading. I want to know what is this device is called and what reading does it gives. Meanwhile, I will check your comments. Wait for it. Yes, very good. Speedometer. Now this speedometer tells this thing instantaneous speed. But have you ever wondered how does this thing actually works? It does have a formula. Unfortunately, I can't tell you the formula. But you know what? Let's break the rule here. I will tell you the formula. It will not make sense. You will not understand. You will only understand when you go into the 11th class. Instantaneous speed is given like this ds by dt, or it is called delta s by delta t when these things are very, very small. Now, there's a reason why am I right, what I'm writing, why am I right. First of all, ds by dt is something called calculus. Okay, are you aware of this chapter? Very, very interesting chapter. And if you don't like it, it's gonna be a nightmare for you. So this thing tells about how the small change divided by small change gives you that velocity thing. But again, it doesn't make sense. It will when you go into the 11th. So this is not our topic for the CBC. It is just for introduction. Now, what is the topic for the CBC? Is this right over here, which is average speed or average velocity representation. Representation. No, you know what? Let's directly write the formula. That would be much better. It is represented like V, AVG average, or by these two symbols from maths. Okay, this means total distance or displacement, whatever they're asking for, divided by total time. So that in a simple terms called average speed. But the, this thing looks simple. It has way more things in it. Okay. So what I'm going to do is, as you can see, my board is kind of like filled. You don't have to draw the diagram, but if you could, I would be appreciating it within 2 minutes, not more than that. Take your time, write it down. Meanwhile, I will check whatever doubts you have. Hmm. Okay, there are few. Yeah, total distance. What does the delta means here? Cherry, Kunal, I think that's it. Kunal. Okay, listen, delta, which is given here, I introduced in the displacement delta S meaning S2 minus S1. This is explanation I'm doing. It's not a part of This is not a part of notes, by the way. Delta simply means difference. When you do DS meaning very small delta. Okay. Yes, very good, Varun. Varun is writing the full thing for the average speed, which is the total distance traveled by or in the total time taken. Yes, but be careful about this thing. Okay, I'm gonna soon learn about what is mean by. And yes, hi. In a instantaneous formula, you're asking why is it delta is small? Well, look, simple. Actually, this machine right here measure how much wheels are rotated. If you really pay attention, there's something written here in the what do you call bikes, car, that it is like RPM multiply with 1000. Like when it tells one, it means 1000 RPM. When it says two, it means 2000 RPM. It says three, obviously 3000 RPM. So I guess 2 minutes is over. So I'm gonna do like let you see this thing, and I'm gonna say 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. If you're new to this thing and wondering why am I doing the countdown, that simply means you have a 10-second times to take the screenshot just in case if you're unable to get the notes. Okay. Now let's move on to the formula. And many of you claim that you know this thing. So I want to check whether you really know it or whether you don't. Question number one, it says find average speed and average velocity. Question is very simple. There is a factory which is called factory A, and there is a factory B over here. You know what? Let's not have a factory because that would be too cruel. I mean, sending person from one factory to another factory. What happens to the labor law? So let's suppose this person or this worker has small thing called home, and this is workplace. And you know how things work. First, the person will go there by walking because doesn't want to go there willingly, but come back to home running. Or you know what? We can make this thing like a school also. For your perspective, it's kind of like a factory. So the distance between them right now is 200-meter, and here speed is let's take the simply walking speed 1 meter per second, and running speed, let's say 2 meter per second, twice the speed. Now the person started at, let's say, 8 o'clock, and reach there, then spend, and let's pretend it's a quick class, like really quick class, 20 seconds, and then run back, basically. Yeah, it's a very fast class. My question is, during the entire journey, what would do you think the average speed the person have? Now I'm gonna give you time. This is not an easy question, but I believe you can do it, and then I will explain. Okay. You know what? One more. I want to change something, but I will take this thing as a second question. But right now, you got 1 minute. Do it right now. I will check the comments whether you got the answers or not. Yeah, does this topic, yes, it's definitely linked to the JEE mains or shit. Yes. Oh, some people are already getting the answer. I will say one more time, there is no mention of time, how much it traveled. Time for traveling is not mentioned. That 20 second is spending time, spending in that school, which looks like a factory. Okay, okay, we're getting answers. Now, first thing which I really appreciate, and I was like thinking many of you won't be getting it, but you did got it, and that is the average speed, sorry, average velocity is actually zero. Wait a moment. Why? Why is it zero? Well, quite simple reason. Displacement, which is total, obviously, is zero. It came back to the home again. So be careful about this particular point. Many of the questions try to trick you. Don't get tricked. Okay, you're smart people. Now, second, which is the actual calculation, average speed. And I want to know how many of you actually got it. Listen very, very, very carefully. First, total distance is gonna be 200 plus 200. Agreed? Is it okay? 100, 200, going and 200 coming back is fine? Fine? Good. Now I want to check whether it is fine or not. First of all, T1 time here is going to be 200 divided by 1, which is simply 200 seconds, not a big deal here. And T2 time here is going to be 200 divided by 2, which is going to be 100 seconds. Now, how many of you just written 200 plus 100? You can see I'm going to write something which is going to be feel weird to you. That time spent will be counted in it. Yes, yes, indeed, it will be counted. You may be thinking, sir, wait, isn't supposed to be the time for traveling? Look and listen very carefully. If you have seen any advertisement for the any vehicle, when they mention that they have a car which is having a mileage 20 kilometer per liter, or maybe a bike which has or scooty have a mileage of 60 kilometer per hour, 60 kilometer for per liter, they never do for like only traveling. They actually like accommodate entire thing. For example, if you ever did with your family, of course, any car trip or bus trip, you will say, I went to my village, which is 200 or 400 kilometer from here, and it took like 12 hours. You did not said mention this thing that in between you have took the break, have a food, get yourself fresh, but you only mentioned that it's a 12 hour. You're basically counting the spending time also where you are not traveling. That is the one thing you need to understand. Have total time means total time. Is that clear? This is important. So because of that, 400 divided by 320, you can cancel it of course by 80, 5, 4, 1.25 meter per second. Is that clear? Any doubt? Once again, somebody is asking how did I took that time? One more time. It is supposed to be total time. Time for going, time spending, time back. Easy peasy. Just take all the time. Okay? Not too much time for solving the question. Is that fine? Okay. So I will say once again, my board is kind of filled. I will give you 10 seconds to take the screenshot and let's move on. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Now there are some doubts regarding this question, so I will just do a small summary. Ready? Okay, listen. First, total distance is gonna be 200 going and 200 coming back. Total 400. Fine? Good. Next thing is time. Time to go there is, speed here is 1, distance here 200. So time is gonna be taking 200 seconds. Then here it came back 200 meter with the speed 2 meter per second. So total time is gonna be 100 meter per second, 100 seconds because distance by time. Now that is going time, that is coming back time, and that is a spending time, meaning taking rest. Okay, so hence the total time. Is that clear? Is it fine? Okay, good. Can you please, okay, take the screenshot. I'm just gonna do for once now. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Done. Now, since you understood the main formula, let's build over this thing even more. Listen very carefully. Depending on what case you are going to get, you get a different formula. The main formula is still total distance or displacement by total time. Total time. That is the formula. However, depending on which datas are given, it will be divided into three parts. I'm going to write all of them. First, you may get distance and time. Distance is gonna be d1 and d2, and time is going to be t1 and t2. So for this, it's same as the main formula. Just take the total distance by total time and we are done. However, sometimes they give sometimes they give speed and time. Like saying a car is going 54 kilometer per hour for 1 hour, something like that. So speed here is like V1 and V2, and time here is T1 and T2. So what happen is V average is equals to, now listen very carefully. Writing time is not an issue. It's right there. T1 plus T2. Done. Easy peasy lemon squeezy. However, writing distance is difficult. It's not if you just realize that all you had to do is v1 t1 velocity into time plus velocity into time. That is a change you are getting here. I'm gonna put this thing in a bracket. Now another one is even more interesting. What if distance, which is d1 and d2, and velocity T1 and T2 is given. So here we average is gonna be, distance is fine, D1 plus D2, but how do we write time here? Oh, sorry, my mistake. How do we write time over here? Well, quite simple. D1 by V1 plus D2 by V2. Is that clear? So depending on which question you are doing, like which information you are getting, you are going to use any one of the formula here. Okay? Oh, somebody is asking why average velocity was zero in the previous question, because the person went from home to home. Total displacement zero. Okay? Now, you write this saying, I'm gonna check some comments, whatever doubts you have for 2 minutes. Oh, somebody actually gave the photo. Hitesh Agrawal. Thank you. Really. What does the autometer is actually a device which you can find in every vehicle, which tells what is the instantaneous speed is. Somebody is asking what is the exam timing. I believe the maths sir have already given you the brief that it's a 2 hour examination or something. But Let me tell you something as a personal. Meanwhile, you write this thing. Be ready for anything. Yeah, that's the best advice you can get. I'm gonna give you a small news also. Are you aware of this NEET examination, by the way? NEET examination? Yep. You know what happened recently? Yeah. So imagine that can happen on all India level. So that's why be ready for anything. The test paper can happen again. The test paper can be lengthy. The test paper can be short. If you are lucky in life, which highly unlikely, you might get an easy paper, small paper. But again, that depends on pure your luck, which you will experience in life that you hardly get lucky actually. Anyway, so I believe this formula which is written over here is done. Can I assume this thing? Should I move on? Come on, tell. Seema, I think I can try. Oh, somebody is even given the best. I like when people actually do extra stuff. I'm supposed to give you something here, like what if the D1 and D2 are same? And you know what? Some people are actually writing that formula. I really appreciate this thing. Really appreciate. And Sahashri, you are saying that my voice is low. Okay, I will try to increase it. Mani, you are asking for recommended book for Jay. As of now, you just need to do what we give, like resonance book, because it contains whatever you need. Believe me, I know, and I'm not saying because this, because whether you take this book or any other book, let's say H.C. Verma's Engage and this Aryant one, they have more or less same question. Okay, I'm just gonna wait for 2 minutes because this thing is important. Yeah, DC Pandey, Aryant publication. That's correct. I'm gonna wait for 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Now let's do practice because knowing formula theory is one thing. Like I would consider it's like 30% of physics. Mostly or everything you're gonna get in the paper, 70% it's gonna be numerical. Okay? All right, ready? Here we go. First question. And let's start with something like a familiar thing because I just want to check whether you understood or not. That's all. And let's see who can give the answer quick as possible. So here we have a distance d1 which is 100 meter and it was done in t1 time which is 10 seconds. Then the person took rest because if you really think about it, that's 100 divided by 10. That is, who's the fastest person in the world right now? Fastest person? It's record. Yeah. So obviously the person needs to take a rest. So resting time when it is not moving is 10 second. Then it went again the fastest man person, the Usain Bolt, 100-meter, and the time again took 10 seconds. Oh, he's better than running, at least better than me. Now, I'm going to ask very simple thing. Now tell the answer. Tell the answer. Tell the answer. And I'm getting a lot of people giving correct answer. Just small percentage of people not getting the correct answer. Okay, I like the creativity with the image, whoever sent that. And now I'm getting all of them correct answer. Listen, very few of you are not getting it, but that's why I'm here. Solution is this. V average simply means total distance 100 plus 100 divided by total time 10 and resting time 10. I'm just gonna mention it again. This resting time would be included. So giving it as 200 by 30 ends 6.67 because we know it's gonna repeat itself over and over again. Is it okay? I believe so. So we are going to do the next one. Ready? I'm gonna count up to 10 seconds once again. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's move. Next is question. What should I give? What should I give? Yeah. If V1 velocity is 60 meter per second and V2 velocity is 30 meter per second for equal amount of time in a straight line, then find V average. I will tell you right away what the question is giving. It giving V1, V2, velocity and equal time, which means they are giving the information regarding time. So I don't want to say it, but you get the idea, T1, T2. You know which formula to apply? Do it. I want to check the answer. So let's see. Okay, that was good. Very good. I see no wrong answer here. None. And that's an awesome thing. So you know what? Why delay? I want to tell you sort of like a note point also, which may help you in future questions. Future questions like whenever they say equal time, this. The moment you see something like that, direct answer is V1 plus V2 by 2. Why is it this way? Because you would be having T and T here and T here and T will cancel each other to make coffee. Sorry, my mistake. They will cancel each other and you will get by 2. Is that clear? Is that fine? All right. Let's move on to the next question and let's change something. Hmm. You probably can guess what I'm gonna change. Probably. You can tell what I'm changing. There we go. And you know what? Let's make things exciting. Should I make it exciting? I think it's fine. Take your time. Yeah, that would be fine question. So let's check the answer. Whoever said it's a cube root of 55, I don't think so. Hmm. Hmm. That's correct. Very good. Very good. Somebody says, can I explain the note point? Yes, I will. I will definitely. Some people are not giving the correct answer. Many of you are giving the correct answer. So many that the chat is going with the speed of light. Okay. So let's see this one. First of all, I'm going to explain the previous one, the previous formula, just in case, just in case. So listen carefully. If T1, T2 are same, let's say some T, capital T, then V average is gonna be V1 capital T, V2 capital T divided by 2T. Now I'm gonna do something and I hope it will not mess up your mind. If you have like, you can cancel them by the way. I hope nobody will say, sir, why are you canceling one T with other two T's? Do not say this thing. You can take the upper T as common to get the final answer. Is that clear? Fine. Now, let's deal with this one. Now, this one, the formula goes something like this: V average is equals to D1, D2 divided by D by V1, D by V2. I'm doing the explanation first, then writing the formula later. Here again, you can take common and cancel them because you can, and then you get the final formula, and that would be V average. Pay attention, we're gonna do something called smart calculation. This is gonna be V1 V2 multiply and above V1 plus V2, right? So here we get 2 V1 V2 by V1 plus V2. Done. Okay, but that's a formula. Where is the answer? Now for answer, I just need to do this. 2 into 60, 30 divided by 60 plus 30. Okay, and whenever you do the calculation, try not to do the brute force here like, sir, I'm gonna multiply everything, sir, I'm gonna divide plus everything and then divide. Don't do the board mass stuff. Okay, be smart here. This is gonna be, let it be 260 and 30. This below one is gonna be 90. After that, you can do the canceling stuff. 3, then cancel this, you get 20, and you just get 40 as an answer. Is that clear? Any doubt? If no, then you know what I'm going to say because my board is kind of like filled. So I'm gonna check the comments if there is any doubt. And if you have, I will simplify this thing, solve your doubts if there is any. If not, then I'm gonna wait for 2 minutes. Oh, Bhuma Abhinav, I appreciate the creativity. And okay, I didn't see much. Okay, sir, please explain the last two step again. Joe hit. Okay, listen, the last two step here is, I believe you are asking for right here. Listen, this is 1 upon V1 plus 1 upon V2. Okay, so all we need to do is take the LCM, which is gonna be V1 plus V1 into V2, and right here we are gonna get V1 plus V2, something like this. I'm gonna do something like extra here. 1 upon V1, 1 upon V2 is like V1 V2 and V1 plus V2. Something which you learn probably in the chapter of maths called fraction. Yeah, that's the one. So do this right over here. Okay. Oh, somebody is giving a question. You know what? I will check this thing. It will take some time. I'm gonna sacrifice some. I have to sacrifice something, I believe, but I will check. I appreciate the creativity, but I mostly appreciate if you actually do the solving part also. Okay, there's a question. Oh, you know what? I was about to give that question. Who's that person, by the way? Chandra Has. Nice recommendation. I will give you that question. Okay. Yeah. You know what? I kind of like deliver this lecture in a way so that it feels easy for you, but I know some of you are actually bit more have, kind of like wants to have more intelligent type question, wants to have a question which challenge you. So just because of that, oh, sorry, my counting by the way. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. There we go. I'm gonna give you a question which you all wanted to know. Question is V1 60, V2 20, 30, and V3 20 meter per second for three equal distance. You can also consider that they have completed one third of their entire journey, one third, one third, one third equal distance with these speed. Then what is V average? I'm just gonna wait for 30 seconds because I know some of you already have the answer. Oh, that somebody's telling me, sir, you did not reveal the answer for the yesterday question. Thank you, woman. I will appreciate the reminder. I will do it now. Now means at the end of the class. Hmm. Good. People are giving correct answer, which means you can actually like take even a slightly difficult question as well. Maybe it's just me, my psychology work like that. Whenever people do a bit better, I just make their questions a bit difficult, probably. Oh, very good, very good. So many correct answer. So I believe you already know this thing, but just in case, I'm going to write it. Solution. Whenever you get a distance same, you can apply this formula by the way, V average, and here you can put something called N. N is gonna be like V1, V2, dot, 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 Vn. I'm going a bit technical over here. This is going to be equals to 1 upon V1, 1 upon V2, 1 upon V3, and up to 1 upon Vn. You can do that by the way. That's kind of like a mother of all formula, you can go say. But suppose we are not actually going to do this, let's do it in a simple way. So in a simple way, it's going to be something like this. V average is going to be distance, all of them are same, divided by distance divided by velocity v1 plus distance divided by velocity v2, distance divided by velocity v3, and we would be getting first of all 3d, not because it looks 3d, because there are 3 and d. And then d common here, which is gonna be 1 upon v1, 1 upon v2, 1 upon v3, and these two got cancelled. You get 3 times of v1, v2, v3 divided by v2, v1, v2, v3, and v1, v3 is equals to v average. Or you can just stop right here in the second line right here. That would also do because right here we can just put the formulas, get the answer. And I'm gonna do just that. So here we are going to get V average is equals to 3 divided by 1 by 60, 1 by 20, sorry, 30, and 1 by 20. And I believe you know how to take LCM and stuff, solving it. You're gonna take 60 here, you're gonna get 1, 2, and 3, which is like 6 divided by 60. Basically, answer is gonna be 30 meter per second. Is that okay? Yeah. Is that fine? Yeah, correct. I yeah, some name is there. Yes, the JE advanced paper is going to be soon. You got 20, Mokshit? Do check it. So there is two. Where is two? Did I mention two? Where is two? In the formula? Did I mention two over here? Anyone? Anyone? Okay, no doubts. Up until now, okay, just somebody is asking for, sir, can you explain one more time? Good. Okay, I do that. Simple. Don't look at the green color, it's bad. Look at the yellow color and blue color. Yellow color says total distance divided by total time, which is d by v1, d by v2, d by v3. Done. D don't know. So eliminate this thing. Bad thing. Cancel it. You got that. Then put the values which is given in the question. Solve it with mathematically. When you solve it, magic happen, you get 30. See, my explanation is kind of like a short one. Anyway, I believe it's done, so I'm gonna give you one last question, okay? And I'm pretty sure, I want to be surprised. Pretty sure you're not going to get the answer. Final. I'm not gonna go beyond than this, okay? And you will get time, like 5 minute time for this one. Try not to do any search. Look, get it from your side, like challenge yourself. Even if you fail by yourself. Ready? Ready? I'm gonna count it to 10. Remove this. Last question after that. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And I don't want to bore you with the words there. I will simply give you the question. There is a total journey of distance capital D, half of the distance which is called d by 2 and another half of the distance d by 2. Now this half distance is completed by speed called v naught. Okay, I repeat, it's called v naught, the zero in the downward suffix called v naught. However, the other thing is actually divided into two parts. How is it divided into two parts? It took total time something called T naught and they divided into two parts, T naught by 2, T naught by 2, which took different velocity called V1, V2. Now the question is simply asking V average. You know what? Let me help you out here. Let's suppose I said V average is equals to A V naught bracket V1 plus V2 bracket close divided by B V naught plus V1 V2. Find A plus B value. Now this is not a simple question, so I will explain two more times, not one, two, okay? The total journey, let's suppose it took 100 kilometer. Got it? 100. 50 kilometer done by a single speed called V naught. Good? Fine. Another 50 kilometer, which let's say happen in 2 hours. 1 hour with this V1 speed, another hour with this V2 speed. So three speeds are there and they are not doing equal distance and equal time for all of them. Be careful. It did equal time here and then equal distance there. And V average came out to be something like this. You need to find A and B value. That's my first explanation. Second explanation, I will do it again. Here you need to apply a formula which is like V1 plus V2 by 2, which I shown you in the previous question. And for the entire thing, the formula which I shown you something like 2V average is equals to 1 upon V1 plus 1 upon V2. Try doing that. And I know that it's gonna be a difficult question unless you're doing cheating. Don't do cheating. Look, you can cheat to me, okay, because online I can't see what you're doing. I can't even see where are you right now. Are you on the bed? Are you on the table? Are you on the floor? I have no idea. You can cheat your parents also, you can cheat your siblings, which is a bit difficult, but you can. But you cannot cheat yourself, okay? Look, if you achieve something difficult, you know you did this thing by yourself. Recognition. So take your time. I'm gonna give you 3 minute. I didn't never gave 3 minute before, have I? No. Take 3 minute time, solve it. Somebody is asking for physics notes relentlessly. Varun Reddy, you're asking for physics notes. I believe it would be shared after the class for this one, of course. And Abdullah, you got the answer, and as well as Abhishek and Vishnu Charan, you're so close. B is not what you written. Um, Mithul, yes, that's correct. Abhishek, that is also correct. Muhammad Asif, that is correct. Wait a minute. How we are getting correct answer so fast? It's not even been 2 minutes. Okay. Ananya, you are saying you do not understand the question. No problem. That's why I'm here. I'm gonna explain one more time. Imagine 100 kilometer was done in 4 hours, something like that. So 100 meaning half of 150 is done with V naught, and this 50 took like 2 hours, which is divided half half. 1 hour here, 1 hour here with V1 V2 speed. I'm kind of like combining two concepts into one. It's not just velocity and time, it's not just velocity and distance. I'm combining. That's make the question difficult. And many of you people getting the answer while I was explaining this thing. I'm sorry I can't say your name because there's so many answers. But I will say which one is not correct one. Vishnu Charan, there's something needs to be worked on. Sharad Tej, correct answer. Seema, correct answer. Just one sign. Yeah, you need to do that. You haven't got the answer. Charit, yes, very good. Kartike, I think you are way off with your answer. Please check. Akshat, you are asking, explain. I will in the solution. And there are so many names. Correct, 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 and correct again. Okay, okay. Some people are saying, "Sir, I understand the question, but I don't know what to do." This question is actually like that. It's supposed to be challenging question. So listen carefully. I'm gonna solve it right now, so it won't become another homework, unexplained homework. It's very very easy. Here you are going to get velocity called v1 plus v2 by 2. Agreed? Say yes, sir. Come on, say it. Good, very good. Now here is V naught, and it happened for half hour distance. What was the thing I told half distance? Half distance, you can write 2V average. You know that mother of all formula? 2 divided by V average is gonna be 1 upon V naught plus 1 upon V1 plus V naught or V2 by 2. And after that, just use something called maths in physics, and magically you will get the answer, which would be A equals to 2, B equals to 2, and A plus B equals to 2. And you should consider this thing as an achievement. Do you know why? Because many of you did the answer and I tricked you in this thing. Somebody even posted their notes. I really appreciate that, the entire solution you did. Thanks. I actually tricked you guys. This is IT JEE mains question. You haven't even started the JEE mains question and you got a JEE mains question correct. Do you know how big it is? You haven't even started the preparation. So consider yourself a bit relentless candidate who's not giving up. And those who did not got, maybe almost got, because some of you are saying its answer is 2 plus 1 or 3, something like that. Let me tell you one more thing. As long as you are trying, you will never fail. That is the one true nature you need to remember for your life entirely. Those who fail are the one who do not try. Okay? So I will just tell one more thing. And yes, chat GPT, of course, because some of you are saying that. Look, I understand people do not see what the other person is doing, so that could be, but never let this thing to decrease your value. Okay? There are some genuine people who are actually doing the hard work, so be that genuine person. So one more time, I'm going to explain in a quick way. We got total distance divided into two parts, V naught speed, V1, V2, half time. So half time, this formula, which we have seen in the example. Then I took that as a speed for half distance. That's a speed for half distance. Applied mother of all formula thing here. Then did some mathematical magic and we got that. Okay, now I'm gonna say again 10 seconds. You're gonna take the screenshot, and that would be it. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Now, finally, I would say thank you for listening, and I hope you learned something. And let's meet in the next video. And somebody keeps saying, "Sir, one more question, one more question." You know what? I will remember that request tomorrow. Okay? So let's say, yeah, that's it for today.
Good morning, everyone. Okay, so let's start today's chemistry class with it. In the last class, we completed our quantum numbers part. Principal quantum number, azimuthal quantum number. Good morning, Karthik. Okay, so today we have to complete with atomic structure part, in which electronic configuration and rules for writing electronic configuration we will cover. Okay, so just focus on the part. Exam syllabus is this basics of chemistry, first topic, and second, complete atomic structure till electronic configuration. Okay. But they are sharing, they will share, na? I asked to the concerned technical team, they will share you. So let's continue our topic. So heading is the rules for writing electronic configuration. Rules for writing electronic configuration. This is our heading beta. You can say like filling of orbitals also. Ab in the lower classes you studied writing of configuration, okay? Writing of electronic configuration like sodium you studied 281, है ना? So that time you are studying only on the basis of shell. कि in different shell how electrons are present beta. Like calcium, can anyone answer beta? For calcium, what was the configuration, electronic configuration? So calcium atomic number is 2882, है ना? This you studied 2882. But now we know about कि there are energy levels shell, there are sub energy levels beta subshell. In the subshell we have degenerate orbitals, है ना? Orbitals present, or in the orbitals electron can be in different spin beta, है ना? Clockwise spin or anti-clockwise spin. So here what we are going to discuss ki how to write the filling of electron. Okay, it is decided by three rules. Okay, which is first I am going to discuss beta. It is above rule. First is above principle. Above principle. What is this above na? It is in German word, beta. It means building up. Building up. Above is a German word which means building up. Building up means beta how we are creating anything. Well, because always from the lower energy level to higher energy level. From the base, we will build the base first, then first floor, second floor, third floor, like this. So filling of electrons always happens in an increasing order of energy. Okay, means what we can say according to it, you know, electrons are filled in increasing order of energy. Increasing order of energy. Electrons are filled in increasing order of energy. What is the meaning of it? It means, okay, that is electrons are filled first, are filled first in that orbital or in those orbitals, okay, which have lower energy, which have lower energy. Okay, what it suggested? Ki electrons are first in those orbitals which has lower energy. Okay, correct, correct, beta. You are answering correct, है ना? But this for all I am discussing, you know it's very good. Chalo, so electrons are filled first in those orbitals which having lower energy. How to decide the energy order here? This is the important part. Okay, how to decide the energy order? For this, we have n plus L rule. Okay, n plus L rule. So, what is n plus L rule? In the n plus L rule, there are two cases. Okay, case one, case one. If n plus L is different, if n plus L value is different, okay, if n plus L value is different for two orbitals, then electron, okay, filled first, filled first, which is having lower value, which is having lower value of n plus L. Okay, n plus L. N plus L beta you're able to calculate now n plus L value. हाँ Naman, correct. Least value or lower value of n plus L. Like if I take the example, energy order beta 1s and 2s. Okay, 1s and 2s. So what is the n plus L value for 1s? 1 plus 0 1. Okay, and for 2s 2 plus 0 2. So n plus L value is 1 and 2. So where electron will go first beta? Electron will first in 1s orbital, means this is the energy order. Energy order. 1s energy is less than 2s. So electron will first fill first in 1s, then electron will go in 2s. Achha, what is the maximum capacity of s subshell? In the s, how many electron can fill? Only 2. Yes, Anush, correct. 2 electrons can fill, then 2s will fill. After, if we have electrons, then we'll go for 2s. Okay, chalo one more example with this. Okay, suppose we have 4s and 3d beta. What is the n plus L value? for 4s. What is the n plus L value? 4. Or for 3D, 3D 5. Okay. So energy of 4s and energy of 3D, whose energy is greater? Energy of 4s or energy of 3D, whose is greater? 3D. So electron will fill first in which orbital bit? We will say electron will first in 4s orbit. 4s will fill first after, okay, okay. Before 3D we have to fill the 4s. So this is valid when n plus L value is different for two different orbitals. Clear? Is this clear better? I hope you are getting because everyone is answering. It's a good thing. Okay. So please take a screenshot of it. I am going side. Take it. Any doubt here, beta? No. Good. Naman. Yes, beta. I'll again ask. They will share. Just be in the class till last. Quantum chemistry is different than normal chemistry. But at micromolecular level, na, very small level, there's a classical chemistry or classical physics concept is not applied. You know, there's a like in physics also we will say general physics, non-classical, classical physics, and quantum physics different. Some rules are not applicable at very small level. Beta. Okay, okay. Louder, I am checking. Clear? So next, beta second is case 2. Case 2 is what? If n plus L is same, and if n plus L is same for two different orbitals, okay, then electron filled first in that orbital, having lower value of n. Lower value of n. If it is having the lower value of n, okay, lower value of n. Like example, if I check now, beta, suppose we have 4f, 5d, 6p, 7s. Okay, no, you can make separate notes, no problem. Okay, 4f, 5d, 6p, and 7s. Yes, beta. So, what is the n plus L value? N plus L value. Here, n plus L 4 plus 3, 7, 5 plus 2, 7, 6 plus 1, 7, 7 plus 0, 7. Okay. So, what is the energy orbital? The lower energy orbital is here 4f, then 5d, then 6p, then 7s. So, electron will go first in 4f orbit, then last in 7s. Okay, clear now? So, remember this thing कि if I write the beta subshell, है ना, we have subshell S, P, D, and F, and their maximum electron capacity. Maximum electrons 2, 6, 10, 14 meter. है ना? This is required during writing the electronic configuration. This is required during writing the electronic configuration. अब everyone know this memory map now beta. I am giving you the memory map. देखो here I am taking n values. Suppose n equals to 1, n equals to 2, n equals to 3, 4, 5, 6, 7. Or here I am taking L values beta. L 0, 1, 2, 3, 4. Okay. L0 means, can I say 1s? So here 2s, 3s, 4s, 5s. Okay. This can be 6s or 7s down 8s. Okay. Now, beta, this P, so 1P does not exist now, but 2P exists beta. 2P, okay, 3P, 4P, 5P, 6P and 7P. And D, so 3D exists, 3D, 4D, 5D, 6D, 7D. Okay, then 4F, okay, 5F, like this. Okay, now how to remember the order? What to do better? Yes, yes, correct, correct. So how to do? Very simple. Ki just we have to draw parallel lines top to bottom. Okay, here, देखो, this is top. If it is top, this should be our bottom part. So we will draw parallel lines, and we will connect it. Okay, top to bottom, top to bottom. So what is the order, beta? Yes, yes, correct. So this chart, top to bottom, if we'll remember, this is the energy order of increasing. Okay, like 2P fill first, then 3S, 3P, 4S, 3D, 4P, 5S. Correct, correct. Okay, so take, on the basis of it, if I write the energy order beta, है ना? Energy order, energy order. Then what is this energy order? Energy order. Energy order is like 1S, then 2S, 2P, then beta 3S, okay, 3P, then 4S, 3D, okay, 3S, 3P, 4S, 3D. Then what will come beta 4P. After this 4D. What I'm missing? 3P, 4S. 1 minute. Okay. 3D. After 3D beta 4P, 5S. Okay, sorry, I missed 5S. हाँ. So देखो, this is our third period. If we'll go here, 3P, second, 3P, 3D, 4P, 3P, 4S, 3D, then 4P, 5S. 4P, 5S. Okay, 5S. So this is our beta above principle, है ना? In the above principle, according to this chart, we can easily remember the energy order. Clear? Energy order. So, अब maximum electrons can be filled in the 1s orbital is only 2. 2s orbital, है ना 2. 2p subshell. अब here electron can be filled. Okay. Okay. Screenshot I am giving. Just wait. 3s again 2, 3p, 6 we can fill here. Clear ना बेटा? चलो. Next is है ना after above principle we have to discuss Hund's rule. Hund's rule. Point number 2. Anyone? What is Hund's rule? No, 6f will fill better. Just till now, if we only write till 36, we will get this. Okay. Ah, Hund's rule. All the g-unit orbitals should be half filled or fulfilled. Yes, yes, singly occupied. So what we can say according to Hund's rule, beta, according to according to Hund's rule, okay, pairing of electrons happens in degenerate orbitals in degenerate orbitals of a subshell when all orbitals are half filled, okay, half filled with parallel spin, parallel spin, parallel spin, okay. Spin should be parallel. It means, देखो example I am taking. Suppose we have nitrogen. What is the atomic number of nitrogen? Just wait for now. I'm atomic number of nitrogen is 7. Now I am going to write electronic configuration. With the electronic configuration, if I write, this is the order of 1s, 2s, 2p. Okay. So if I write ki 1s will fill first, then 2s will fill, then 2p will fill. Then how many electrons we are having to fill it? We are having total 7 electrons. So 1s2, okay, 1s2, then 2s2. Electron will first, then beta 2p3. So if I draw a box diagram, S subshell has one S orbital. Beta, how many p orbitals present in p subshell? There are three orbitals: px, py, pz. Three: px, py, pz. More precisely, there are two px, two py, two pz. Okay. So what is the how to fill? देखो, one electron will come. अब s orbital is only one, so next electron will go in the s, है ना? Here 1s2, but spin remains opposite. This is our next rule, beta, which is, anyone give the name, by maximum multiplicity, not simplicity. Maybe it is typo. Multiplicity. Pauli, huh? Okay. So now next electron here, then again 2s2. अब how to fill 2p? How to fill 2p, beta? 2p3 we have to fill. 2p3. So we will fill like this: 1, 2, 3. Okay. Singly means, suppose कि we have 3 rooms or 3 guests. We will give one room for one guest. अब suppose fourth guest is coming, then we can give है ना a paired up or same rule. हाँ, correct, correct, correct. So it is 2px1, 2py1 and 2pz1 with maximum parallel spin. Okay, so this is the correct configuration. Now if I say beta 1, 2, 1. Okay, is this correct for nitrogen? No, wrong. No, this is wrong. This is wrong. It is violation of which rule? Bow principle or Hund's rule? It's a Hund's rule violation. Is it okay? Hund's rule violation. Acha, if I ask beta 1, 2, 1, is this correct? No, it is also wrong. Why? Why it is wrong? Because parallel spin is not there, beta. Wrong spin. Okay, last I want to ask, beta. All are anti-clockwise. Is this correct or incorrect? Some people are saying ki incorrect. It is correct, beta. It is following the Hund's rule. Why? What was the Hund's rule? Ki pairing will happen when all are unpaired. Okay, and spin is parallel, maximum parallel spin. Yes. Okay. So I hope it is clear. So I am giving you time to take the screenshot. This one. Take the screenshot bit. Main syllabus filter from 1st of June we are having the class. Pairing always with opposite spin. अब देखो why we are saying, because this is the development कि first Bohr gave orbit concept है ना, then this is discarded. Okay, चलो next, this one, sorry, not this one, this है ना Hund's rule. Hund's rule is clear ना. If I fill oxygen, चलो oxygen, then configuration is 1s2, 2s2, 2p4. Then how to fill 2p4? 1, 2, 3, 4. Okay. Can you tell me in d orbital when we pair? In d orbital when we will pair? 1, 2, 3, 4, 5. Then 6. 6 will pair in d orbitals. F 1, 2, 3, 4, 5, 6, 7. Then we'll pair in 8. Okay. So next part is Pauli's exclusion principle. Pauli's exclusion principle. Pauli's exclusion principle. Okay. We'll take the examples. Just wait. We'll take all the examples. Pauli's exclusion principle. Yes. So according to it, है ना, no two electrons can have no two electrons can have, okay, same value of same value of all four quantum numbers. All four quantum numbers. Okay? No two electrons can have all the same value of all four quantum numbers. Okay? According to it, what is the conclusion? We can say beta maximum electron in orbital, maximum electrons in orbital is 2. Okay? And their spin always opposite. Opposite means if one orbital will take spin. Can I say like this ki electron is present in the same shell. Two electrons are present in the same shell. It means their n value is same. It is present in the same subshell, then L is also same. Okay. Up suppose it is present in same orbital also, so M is same. But in the orbital, the spin is always opposite. Means S quantum number is different. Like with example, if we discuss, okay, suppose we have helium beta, helium, atomic number 2. What is the configuration of helium? Helium is 1s2. Okay, so how many electrons present? Two electrons. Two electrons. Up suppose for first electron beta, I am going to write all quantum numbers. First electron. Can anyone answer? First electron, all quantum numbers. First electron, all four quantum numbers. N equals to 1, n equals to 1 because it is S subshell L0. If it is L0, then M0, M0. Or if it is M0, and if I am considering this is clockwise, then it is plus half. S is plus half. But for second electron, N1, L0, M0, S minus half. Here, S value will get minus half. So these two electrons are of same atom, they are present in the same shell, they are present in the same subshell. Okay, but the spin in that orbital is different. This is Pauli's exclusion principle. If I write for because this type of representation, is it correct or incorrect? This type of it is incorrect, no? Correct. This thing is incorrect. Or this is the violation of Pauli's exclusion principle. Okay? Because we can't put two electrons with same spin. Okay? So I am repeating better. What is above rule? Above word is a German word. It means building up. Building up means electron will fill in the orbitals in increasing order of energy. How to answer the increasing order of energy of orbitals with n plus L rule? If for two different orbitals n plus L value is different, then electron will first in fill first in that orbital whose n plus L value is low. Okay. Second thing, if we say कि n plus L value is same, then electron will first in that orbital will go in that orbital which is n value is low because it is closer to the nucleus, it is having lower energy. Okay, Hund's rule, pairing we will do after filling all the electrons singly occupied in a degenerate orbitals. Okay, next thing, what we can say beta, no two electrons in the same atom can have all the four quantum numbers same beta. You know, at last they have different spin. So in one orbital maximum electron can come only two. Okay, na? Chalo. Now we can start all the configurations. Yes, yes. Heading is electronic configuration. One by one, I know कि you know these things, but for all beta, some people are also not able to write these electronic configurations also. So one by one, we'll go with. You know, you can answer in the chat. Then, if I'll take hydrogen, one configuration is 1s1. Okay, 1s1. Though, what is the meaning of this one value? This is representing the shell. Okay, this is representing the subshell. S subshell, or this is representing with a electrode. Ki how many electrons present? 1s1 configuration. Okay, then next element is helium 2. We will write with a 1s2 configuration. Next is lithium. We will write 1s2. Now 1s2 is filled. Next electron will go in next subshell. After 1s, 2s will come. So we'll write 2s1. Are you getting it? Okay. Beryllium 4, 1s2, 2s2. Boron, atomic number 5, 1s2, 2s2. Now tell me better. Okay. 1s2, 2s2. Next electron, after it will go in 2p subshell, which is 1, 2p1. Okay. Or we can write for 2p ki one electron is present here. One unpaired electron. How many unpaired electron in boron? Huh? Just 1 minute, wait again. Chats are not coming. How many unpaired electron in boron? Unpaired, not valence. But I am not asking the valence. Unpaired electron is one only. Arey, why two? Unpaired electron is one only, na beta. This 2p1. देखो, inside is completely filled, beta. Okay, 2p1. Next, carbon 1s2, 2s2, 2p2. Okay, how many unpaired electron in carbon, or how will fill carbon? P orbital will fill 1 and 2. Two unpaired electrons. Okay, nitrogen beta we discussed already. 1s2, 2s2, 2p3. 1s2, 2s2, 2p3. Three unpaired electrons. Oxygen 1s2, 2s2, 2p4. 1s2, 2s2, 2p4. Okay, fluorine 9. 1s2, 2s2, 2p5. 2p5. अच्छा, for fluorine, beta, how many unpaired electrons are present? If I fill unpaired, so we'll write 1, 2, 3, 4, 5. Only one unpaired present in fluorine. Okay. Then next is neon, atomic number 10, 1s2, 2s2, 2p6. This is a noble gas. This is a noble gas configuration. Noble gas. Noble gas, zero unpaired electron. Zero unpaired electron. Correct. Correct. Okay. Next, sodium 11. Its configuration can be right 1s2, 2s2, 2p6, and 3s1. Because after 2p6, the orbital will come 3s1. Clear? Now, can you tell me here, better, this can you relate with the old configuration? Like, देखो, 2, 8, or outer shell is 1. 2, 8, 1. What is the name of the outer shell, beta? What is the name of outer shell? Outer shell is also known as outermost shell, valence shell. Okay? This we can say valence shell. What is the name of n minus 1 shell? What is the name of n minus 1 shell? N shell is the valence shell. Then inside n minus 1, what is the name? Penultimate shell. Very good. Penultimate shell. Because this is said to be penultimate shell. देखो बैलेंस शेल इज द nth शेल तो n minus 1 is penultimate shell and next this one is known as beta anti penultimate. N minus 2 shell is known as, this is a terminology, please remember, anti penultimate shell. N minus 2. Okay, so ultimate shell, penultimate shell and anti penultimate shell. Here core shell. Can I write beta sodium configuration in abbreviated form? Sodium electronic configuration in short form with respect to noble gas. देखो, what is the previous noble gas of sodium? The previous noble gas of sodium is neon. So till neon, देखो, here we will use neon in a bracket, large bracket, means till neon it is completely filled. The core is neon. And after 3s1, neon 3s1, correct? Okay. So this is having 1 ampere electron, is having 1 ampere electron or 1 valence electron also. How many electrons present in, okay, how many electrons present in the penultimate shell of sodium? How many electrons present in the penultimate shell of sodium? Penultimate shell, 6 or 8? Do not give the answer in hurry, beta. 8 na? Penultimate shell is 2s and 2p. 8. Okay. Acha. All 4 quantum numbers of this representation. Last electron. All 4 quantum numbers. N equals to 3, L equals to 0, M equals to 0 or S plus half if clockwise arrow is given. Okay. Next is magnesium. Atomic number 12. Now I am writing in short bit only. Okay. So neon 3s2, aluminium 13, neon 3s2, 3p1, silicon 14, neon 3s2, 3p2. Okay, so I hope all are comfortable, so we can write in a fast manner. Hai na? Just take the screenshot of it. Okay, do it fast. Then we will proceed further with in a quick manner. You will get the PDFs. Sure. Chalo. Next, till silicon done na beta. Okay, till silicon. So after silicon we have phosphorus 15. It is neon 3s2, 3p3. Then sulfur atomic number 16, neon 3s2, 3p4. Then beta chlorine atomic number 17, neon 3s2, 3p5. Okay, argon 18. So neon then 3s2, 3p6. Okay, argon is again a noble gas. This is again a noble gas. So like potassium beta 19. Okay, we can write argon, or now electron will go in what? 3D or 4s? According to our above principle, 4s. So 4s1. Okay, potassium. Then after potassium, beta calcium 20. Argon 4s. Okay. So till calcium beta in writing the electronic configuration, any problem, any doubt? Which one? Sharan, repeat. Sulfur. देखो atomic number of sulfur is neon. This. Then how many electrons beta? 16. 16 na? So 3s2 3p4, because till neon 10 is filled, then next electron will go 2 and then 4. Acha, how many unpaired electron? Argon. Argon, देखो argon is till neon 10. अब next electron is going into 3s, okay, 3s, and this is 6. So total 18 electrons because atomic number is 18. Okay, चलो now we'll writing the configuration of D block beta, है ना, 3D series. The first electron will go in 3D. Noble gases, beta, in the periodic table, some gases are present like helium, neon, argon, krypton, xenon, radon. They have completely filled octet outer. They are inert. Okay. Mostly believed that they are not reacting. So noble gases, inert gases. With respect to this, we can write the configuration. How I know ki 4s1 will come? This is beta with above rule. Above rule. Naman, why are you repeating again that negative man electronic configuration? I'm not getting your doubt. है ना? Truly speaking, I'm not getting your doubt. कि can we write the electronic configuration in negative manner? Okay. So next scandium 21, argon till 18 filled, argon till 18 filled. Okay. Yes, अपूर्व. चलो पहले डाउट कर ले. Yes, अपूर्व. The fill the orbital with same spin. It is correct according to Hund's rule. We fill the orbital with same spin. If we fill the orbital with same spin, हाँ, if parallel spin, then it is correct according to Hund's rule. Okay. But if your other orbitals are available or you are filling or pairing, then it is wrong. Like S subshell, है ना? In S subshell we have S orbital only. Okay. Zinc has complete, no beta. Zinc is not having complete configuration. Okay. So which has octet complete, 8 electron in the outer, है ना? Then it is noble gas. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, okay, copper, and zinc. These are the series now, beta. Now 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay. So what is scandium beta? Argon. Up 4s2 is filled now. The new electron will go in 3D, 3D1. Argon 3D1, 4s2 3D1. अच्छा, मतलब अरे ऐसा क्यों करना भाई नमन? नो नो नीड ना. हाँ, करेक्ट यू आर सेइंग बट नो नीड ना. Simple, because electronic configuration they will not ask directly, they will ask the information from the electronic configurations. So if we are getting with simplicity, then there is no need to do it, है ना, with complexity. Okay. Titanium, argon, 4s2 3d2, vanadium, argon, 4s2 3d3. Chromium has a different configuration as we expect key argon 4s2 3d4, but it is found key chromium is having 4s1, one electron here, and 3d5, 1, 2, 3, 4, 5. Total 6 unpaired electrons. 4s1 3d5 configuration. Why I am coming to it? Just wait. Manganese, argon, 4s2 3d5, Fe, argon, 4s2 3d6. Okay. Cobalt configuration is argon, 4s2 3d7. Okay. Neon configuration is argon, 4s2 3d8. Copper, again beta, there is an exception na? In the copper. What is the configuration? So copper, again it is an exceptional configuration, argon, okay, 4s1 3d10, one unpaired only, okay, and zinc, argon, 4s2 3d10. This till zinc we can easily remember beta configurations. Up I am coming to beta copper and chromium. Chromium is, can I say beta half filled? This is in half filled configuration. Or this 3D10 is a fulfilled configuration. Fulfilled configuration. Okay. Now remember one thing. Half filled and fulfilled configurations are extra stable than partially filled configuration. Partially filled means D4, D9. D4, D9 does not exist. D4, D9 do not exist in 3D series. This is a question beta. D4, D9 do not exist in 3D series because D4, D9 configuration, can I say it is a partial filled? है ना? But fulfilled and half filled configurations are extra stable. So these configurations 3D5 and 3D10 will get because these configurations are stable. Ab, how to check why they are stable? Can anyone answer beta? Why half filled and fulfilled configurations are stable? No, copper is not 3D9, copper is 3D10. Okay? Huh. Hund's rule should be followed? No. Class ending time is 11:20, na? Why half filled and fulfilled are extra stable? Octet rule, no, 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 no. Yes, I am answering कि why copper is 4s1 not 4s2. Due to the extra stability of, okay, this is due to, है ना, copper and chromium configuration is due to extra stability of half filled and fulfilled substrate. Half filled and fulfilled substrate. Huh. Why half filled fulfilled extra stable beta? There are two reasons. Listen carefully. There's two reasons. First reason is beta symmetry. Partially filled or half filled, which is having symmetrical configuration means all d orbitals are having 1 electrons. Okay, so full filled and half filled are more symmetrical than the partially filled. So they are even repulsions. Okay, so if symmetry present in the orbital, then it is more stable. Okay, second thing is known as exchange energy. If you are having NCRT na, please revise it today in this atomic structure part. In the last they gave exchange energy. देखो I am explaining कि if we have 1 2 3 4 or 5 unpaired electrons beta, This our first electron can give how many exchanges? One, two, three, four. For the first electron with same spin, it can have the four exchange. Or whenever electron exchange, it releases an energy known as exchange energy. So how to define exchange energy? Energy released when two electrons of same spin present in a degenerate orbitals. Energy released. Whenever energy releases, system gets stabilized. And more number of exchanges always found in the half filled or full filled configurations. Here second can exchange beta. This second can exchange in three ways. One, two, three. Okay. Next, this third electron can exchange one and two, and this can exchange like this. So more number of exchanges present beta. So there are two things. The cause, one is symmetry, second is exchange energy. Exchange energy. Okay? Exchange energy. Clear? Chalo, next part. Ab filling of electron you have to careful for what? If we are filling the electrons, okay? For filling of electron beta explain again exchange energy. चलो फिर से देखो exchange energy what I am saying. Two electrons. Two electrons. Can you tell me this is a partial filled or half filled? It is a partial filled. Okay, this is a partial filled. How many exchange these two electrons with same spin can do? How many exchange it can do? It can do beta only one exchange. One exchange. They can switch one exchange. So in this one exchange, a energy, constant energy is releases. Okay, a constant energy will release. Exchange means they are switching their position, na? Exchange means this is going at this position, this is going at this position. Exchange means switching over. देखो जैसे like I am having this pen here, I am switching it. Exchange. Okay, as simple as that. So more number of unpaired electrons present, more is the exchange and more is the exchange energy. But the spin should be same, no, not opposite beta. Because if the spin is opposite, it is not following Hund's rule, it's not the stable situation. Spin should be parallel. So if in a exchange energy is released, then it gets stability beta. Just this thing. Yes, for chromium configuration violates Hund's rule, correct. Okay. So next beta electron filling with which concept? Electron filling. Above rule. But electron removal, more exchange, more stability, correct. More exchange, more stability. Or more exchange happens when half filled and full filled. Okay. So next thing is, beta, I want to discuss like we have manganese now, beta, manganese atomic number 25, configuration argon 4s2 3d5. My question is how many unpaired electron in manganese? How many unpaired electron in manganese? You will say 5. Ananya, correct. So first answer. Next 5. Okay. But I want to write the configuration of Mn plus 2 ion. I want to write the configuration of Mn plus 2 ion. Mn plus 2 ion. Mn plus 2 ion beta. Mn plus 2 ion. Yes. Mn plus 2 ion. 3d3, 4s to 3d3, 3d3, no 7 beta. Why 7? देखो, these are 2 or 1, 2, 3, 4. 1, 2, 3, 4, 5. 5 unpaired. 5 unpaired. Okay. Up keep in mind, whenever we will remove the electron, it should be removed from the valence shell. I am repeating again. It should be removed from the valence shell, outer shell. Which is the valence shell here? Third shell is the valence shell or fourth shell? Fourth shell is the valence shell. So this is our valence shell 4s. Then Mn2 plus configuration is argon 3d5. Argon 3d5. Argon 3d5. Okay. How many unp electrons? Here unp electrons 5 beta. 1, 2, 3, 4, 5. Correct? Next, if I write beta Mn plus 3, Mn plus 3, what is the configuration? Now we can remove from the 3D. Mn plus 3 will write argon 3d4. Argon 3d4. Okay. Like Mn plus 4. Configuration argon 3d3. 3 unpaired electrons. Okay. So my suggestion is keep practice like cobalt, copper plus 2, copper plus 1, zinc plus 2, write the configuration, we'll discuss that. Syllabus I told na beta, syllabus is basics of chemistry first chapter and second atomic structure, complete atomic structure. Okay, thank you everyone. So we'll meet in the next class. Better revise all your content, okay? Thank you.
Hello students, good morning. Very good morning champs. Good morning, good morning. Okay, so as promised, today we are supposed to complete the chapter of human circulatory system. So I will give you a quick recap of what we learned in the previous class and then I'll complete today human circulatory system. One thing I want to tell you that fortunately or unfortunately, those who have joined late will not be getting the previous notes. Okay, so you prepare with whatever notes you are having, and if you have the material, the CBC material, then kindly prepare from that. Understood? Okay, this is actually I asked the edtech team, but this is the problem, that is not, that it will not be providing you with any of the previous notes. Understood? So SSC board, I did not say CBSC, I said CBC. I said CBC. Xavier Sabine, I said CBC. What you are having now, the B2B. Okay, these concept based classes, whatever you are having right now, kindly prepare from the same. Understood? If you have the material, then do prepare from the material. Understood? Okay, so I will actually revise what we learned in the previous class. I will be revising the entire heart and then I will be moving to the next chapter. Sorry, I will be moving to the next notes. Where can we find CBC notes, Akshaya? There is no finding of CBC notes. Every day, end of the class, the notes will be sent and that's it. No other resource for the notes is there. It is sent on a daily basis. Xavier Sabine, if you were absent yesterday, it is a problem that you are supposed to face. Because see, you are supposed to come to class every day. I am coming to class every day. I am teaching you every day, right? So you people are also supposed to come every day. Got it? Okay. Now, what I was going to tell, I was telling, no, not next chapter, chapter circulatory system. I said next topic. Okay. I think I said by mistake. Okay. So, today we will be completing human circulatory system and in the next class, okay, I'll be telling you what is our plan of action. Understood? Okay, so let us start this. So structure of heart. Heart is a vascular, okay, heart is a vascular, muscular, blood pulsating organ which is actually pumping the blood. Okay, it is present in the mediastinum region, which is the area between the lungs, and its apex is slightly tilted towards left, and its size is that of a clenched fist. Okay, with that is fine. Next, the size and the structure is over. Now coming to the outermost layer, the outermost layer is a double layered pericardium, outer parietal layer, inner visceral layer. Between both the layers we are having the pericardial fluid, which is acting as a shock absorbent. After that, then we have the three layers. Okay, yes, we also know that the outer five parietal ke baad the inner visceral whatever is there is again further divided into two layers. What are the two layers? Outer fibrous and inner serous layer. This was about pericardium. Coming to the wall of the heart, the wall of the heart is usually made up of three layers: epicardium, myocardium, and endocardium. Epicardium, outermost layer; myocardium, middle layer; and endocardium is the innermost layer, and endocardium is the innermost layer. Okay, so this was about the wall of the heart. Now moving to the internal structure. When I talk about internal structure, the internal structure of human heart is made up of four chambers. Those four chambers made two upper small blood receiving thin walled chambers are auricles or atria, and the lower large thick walled blood pumping chambers are called as ventricles. Point to be remembered: which of the, if the question is asked which part or which chamber of the heart is having thick wall, thickest wall is present in the left ventricle. Thickest wall is present in the left ventricle. If you're asked about the reason why is the wall of left ventricle thick, because left ventricle is supposed to pump the blood throughout the body. It is supposed to pump the blood throughout the body. That is the reason why left ventricle is having very thick walls. Okay, upper chambers and lower chambers are separated by a septum. The name of the septum is nothing but, what is the name of that septum? It is transverse groove AV septum or coronary sulcus. Transverse groove AV septum or coronary sulcus. Okay, now coming to the auricles. Auricles or atria are nothing but thin walled blood receiving upper chambers are called as auricles. Both of the auricles are separated by a interatrial septum. It is separated by a interatrial septum. This interatrial septum is having a small hole which is called as foramen ovale, which is usually closing at the time of birth. If it is not getting closed, the condition is called as patent foramen ovale, and if the position of the foramen ovale is called as fossa ovalis, it is called as fossa ovalis. Coming to the right atrium, the right atrium is receiving deoxygenated blood from all the different parts of the body through three caval veins. What are the three caval veins? Two precaval veins and one postcaval vein. Okay, this is what is called as vena cava. Superior vena cava and posterior vena cava. Superior vena cava and posterior vena cava. Okay, this was about the right atrium. Moving on to the left atrium receives oxygenated blood from the lungs. It is receiving oxygenated blood from the lungs with the help of pulmonary veins. That is how it is receiving the oxygenated blood. From the right lung, right pulmonary veins will bring, and from the left lung, left pulmonary veins will bring the oxygenated blood to the left atrium. Right? Okay, so auricles is done. Moving on to the ventricles. When I talk about the ventricles, acha, Here one more point was there, that the precaval veins are not guarded by any valves, but the postcaval vein is guarded by a valve of inferior vena cava. It is guarded by valve of inferior vena cava. Why the precaval veins are not guarded? Because of gravitation it will however move from the above parts of your body, upper parts of your body to the heart. But superior vena cava ke baad, the inferior vena cava has to carry it from the lower parts of your body. So it is opposite in the direction to the gravity, due to which valves are present which prevent the backflow of the blood, which prevents the backflow of the blood. Okay, this was about auricles. This was about auricles. Now, auricles and ventricles are separated by a AV septum. This AV septum is having valves. The opening of right atrium to right ventricle is guarded by the tricuspid valve. Why is it called as tricuspid valve? It has three flaps. Okay, it will be having three flaps. That is the reason. Matlab three gate kind of structures are there. These three gate kind of structures will open so that the blood moves from right atrium to right ventricle. That is the reason why it is called as a tricuspid valve. Moving on to the left side, left atrium to left ventricle is guarded by a bicuspid valve, which will be having two flaps. These two flaps will open and the blood will move from left atrium to the left ventricle. Bicuspid valve is also called as a mitral valve. It is also called as a mitral valve. So these two together, because they are present on the AV septum, they are called as the AV valves. Okay, done. Moving on to ventricles. Ventricles mean there are two ventricles which are separated by a interventricular septum. Left ventricle is usually smaller in size when compared to the right ventricle because heart is slightly tilted towards the left. Left ventricular wall is thicker when compared to the right ventricle because left ventricle is supposed to pump the blood throughout the body, pump the blood throughout the body. These ventricles are internally having certain muscular ridges, triangular shaped muscles. Okay, these triangular shaped muscles are attached to the AV valves. They are attached to the AV valves by the help of strings which are called as heart strings or chordae tendineae, which are called as heart strings or chordae tendineae. So what is done? These heart strings are pulled so that the valves open and the blood moves from the respective atrium into the respective ventricles. Understood? And again they relax so that the valve gets closed to prevent the backflow of the blood. So tricuspid and bicuspid valve allow the movement of oxygenated and deoxygenated blood into the respective ventricles. Whereas the management of the opening or closing of, who is supposed to open and close these AV valves? It is nothing but the heart strings, which are the strings which are attached to the ventricular wall. Is it clear? Okay, other than this, we are having the arches, aortic arches. There are two aortic arches. One is the systemic arch and the other one is the pulmonary arch. Systemic arch, SOL. Systemic arch carry oxygenated blood from the left ventricle, okay, which is also called as aorta, which is also called as aorta. Point to be noted, if this is not written, put a star and write it in your notes, that aorta is the largest artery. Aorta is the largest artery. The second one is pulmonary arch, okay. This pulmonary arch is carrying deoxygenated blood from the right ventricle. PDR, pulmonary arch, carry deoxygenated blood from the right ventricle. Okay, so this is very important. Next, these two arches, aortic arch and pulmonary arch, they are guarded by valves. Together it is called as semilunar valves. Together it is called as semilunar valves. Okay, and The valve which, the semilunar valve which is lining the, which is present at the entrance of pulmonary arch is called as pulmonary arch valve, and the one which is guarding the semilunar, or when which is guarding the systemic arch, is called as the systemic valve. It is called as a systemic valve. Point to be noted, what is our heartbeat? Write the points. If I am adding some new points during revision, add up those points. Okay, now there are actually two sounds of the heart. What are the two sounds? Lub, dub. What are the two sounds? Lub, dub. So it is lub dub, lub dub, lub dub. Our heart beats like lub dub, lub dub, lub dub, right? Okay, now lub sound. Why does the lub sound comes? You remember AV valves? When these AV valves close, the sound made is lub. When these AV valves close, the sound made is lub. And when the semilunar valves close, the sound made is dub. Okay, so the lub sound is because of the closure of the AV valves, whereas the dub sound is because of the closure of the semilunar valves. Okay, so this was about aortic arches. Last but not the least, in the structure of heart, we learnt about specialized tissue. What is that specialized tissue? That specialized tissue is nothing but the nodal tissue. Okay, there are two types of nodal tissue, SAN, AVN. SAN is sinoatrial node, which is present on top right corner of the right atrium. The function of SAN is to produce action potential. Okay, produce action potential or the electrical impulse. This electrical impulse, because it is conducted by the SAN is called as the pacemaker of the heart. It is called as the pacemaker of the heart. Now, this electrical impulse from SAN moves to AVN, which is present at the bottom left corner of the same right atrium. This is what is called as the relay point, because AVN's function is to receive the electrical impulse from SAN and transmit it to the AV bundle, and from AV bundle it is moved further into the Purkinje fibers. It is moved further into the Purkinje fibers. Okay, so this was what we learned in the previous class. Now we will be moving on to today's class. Before that, let me answer your questions. When does dub sound come? Closure of semilunar valves. Why is the SAN called as a natural pacemaker even though cardiac muscle cells can generate impulse to some extent? Cardiac muscle cannot generate electrical impulse. Okay, it is capable of carrying the electrical impulse. Okay, the contraction, I'll tell you, the contraction and relaxation. Okay, the contraction and relaxation of this auricles and ventricles is because of the electrical impulse which is conducted by SAN. That is the reason why SAN is called as the pacemaker of the heart. Is it clear? Ma'am, sorry to interrupt with an out of topic way, but I am a BiPC student, so is it fine? Yes, your wish. If you're a BiPC student, why will you listen to maths class? Okay, Xavier Sabine, the size of the heart is that of a clenched fist. Heart strings are nothing but the strings which are actually attached from the walls of the heart to the AV valves. These AV valves will be opened and closed. Understood? Okay, because of the heartstrings, nothing there. This is a gate. Okay, suppose this is a gate. I am holding two strings. I pull, the gate is opened, blood enters. I push, the gate is closed. Blood will not go back. This is the function of heartstrings. Got it? Okay, when can we hear the sound lub? When these AV valves get closed, the sound lub is heard. Okay, so this was about the structure of heart. Today we are going to learn about the blood grouping system. We are going to learn about the blood grouping system. So, There are, in total, there are four types of blood groups. There are four types of blood groups. Okay, so the four types of blood groups are, the four types of blood groups are A, B, AB, and O. These are the four types of blood group. Okay. Now, who discovered that there will be four types of blood group in case of human blood? Okay. The four types of blood group was discovered by the person Karl Landsteiner, by the person Karl Landsteiner in the year 1990. In the year 1990, Karl Landsteiner said that human blood is having four different types of blood group. Point to be noted, blood group is genetical. Whatever is your blood group will be having the genes of your mother and father. Okay, so genes from your mother, genes from your father, the blood group genes come, and out of which you get the blood group. Understood? So blood group is genetical. Blood group is genetical. Now what exactly is this blood group? When I talk about blood group, if this is an RBC, if this is an RBC, on the surface of RBC, there are certain surface antigens. There are certain surface antigens. Okay, now based on what type of surface antigen is present on the RBC, okay, based on what type of antigen is present on the RBC, we can tell about the blood group. We can tell about the blood group. So this is a tabular form. Let me show you. This is the antigen on RBC, antigen on RBC. This is blood group. Okay. Then we also talk about antibody in plasma, antibody in plasma. Okay. And we talk about donor. We talk about donor. Just a sec. Okay, fine. I'll write the recipient on the other side, okay? Because I don't want to disturb anything out of here right now, or I can just make it short. That will be better, because or else you people will get confused. I write antigen on RBC. AG means antigen, okay? Antibody in plasma, antibody in plasma, donor, recipient. Okay, donor and recipient. Now let us talk about each one of them. The blood group A, the blood group A will be having antigen A on the surface of the RBC, will be having antigen A on the surface of the RBC. If suppose this is it, this is antigen A. Blood group B will be having antigen B on the surface of the RBC, will be having antigen B on the surface of the RBC. Okay, next blood group AB will be having, blood group AB will be having both antigen A, will be having both antigen A and antigen B on the surface of the RBC. Antigen A and antigen B both are present. Moving on to the last one, that is O blood group. Okay, O blood group will not be having any antigens on the surface of the RBC. Okay, so there are no antigens on the surface of the RBC. Okay, got it? Got it, Nana? Okay, now moving on to the antibodies. Whatever is the antigen present, what are antigens if they are none in O? Is it okay? Yes, yes, it is absolutely okay. Antigens are small protein substances which are present on the surface of the RBC. Okay, understood? I will tell you what is rhesus factor. First, you're supposed to learn this. Okay, yeah. Now coming to the antibody, whatever is the antigen present on the surface of RBC, there is plasma. Opposite antibody will be present in the plasma. So here in case of antigen A blood group, the plasma will be having antibody B. Plasma will be having antibody A. Plasma will not be having any antibodies. Here the plasma will be having antibody A and antibody B. Antibody A and antibody B. Now coming to the next one, that is donor group. Who can donate the blood to A blood group? It can be A or O. Who can donate the blood to B? It can be B or O. Who can donate the blood to AB? It can be A, B, AB and O. Who can donate the blood to O? Only O can donate the blood. Okay, only O can donate the blood. Next, coming to recipient, A can donate the blood to whom? Understood? Donor means taking, recipient means who is give. Okay, matlab here recipient means to whom can it give the blood. A can give the blood to A and AB. B can give the blood to B and AB. AB can give the blood to AB. O can give the blood to O. Okay, wait. A, B, AB and O. A, B, AB and O. Got it? Now, in this tabular form, can you people see that in donor, okay, in donor, O blood group can give the blood to anyone. Can you see that? Yes or no? So that is the reason why O blood group is called as universal donor. Universal donor. And if you see the next case, AB blood group can receive the blood from anyone. AB blood group can receive the blood group from anyone. So it is called as universal recipient. If your blood group is O, you can donate blood to anyone. If your blood group is AB, you can take blood from anyone. So AB is universal recipient, whereas AO is universal donor. Okay, so till here everything was clear, but now comes a little complicated part. On the surface of RBC, there are antigens. Okay, there are antigens. Other than these antigens of A, B, there are certain other antigens as well. These are what are called as RH antigens. These are what are called as RH antigens. Okay, now what are RH antigens? Okay, Zawiya Sabine, notes will be shared. You will have recorded online classes also. Okay, yes. So RH antigens are other antigens which are present again on the surface of the RBC. Okay, if RH antigens are, if RH antigens are present, if RH antigens are present, the blood group is RH positive. The blood group is RH positive. If RH antigen are absent, the blood group is RH negative. The blood group is RH negative. There comes the case of A positive, B positive, O positive, AB positive, A negative, B negative, O negative, AB negative. Okay, so other than these A and B antigens, if there are RH antigens also, then it is what is called as the RH positive blood group. If there are no RH antigens, then that is what is called as the RH negative blood group. Okay, these antigens were found to be similar to surface antigens, similar to surface antigens present on RBC of rhesus monkey. Rhesus monkey. Okay, one of the scientists found that the RBC of rhesus monkey is having certain antigens which are also present in the human beings. So he named it as RH factor. So he named it as RH factor. Okay, point to be remembered, a positive blood group person can take blood from only positive person. A positive can take blood from only A positive. B positive can take blood from only B positive or O positive. Understood? Okay, so because a positive person can take, positive person means positive blood group person. Okay, you don't think, Hare, be calm, that is positive. No, a positive blood group person can take the blood from only positive blood group person. But the condition of a negative group person, negative blood group person can give blood to any of them. Okay, can give blood to negative, can give blood to positive as well. That is the reason why I take a star point over here, that when I talk about when I talk about universal donor is O negative. Universal donor is O negative. Okay, now when I talk about universal recipient, then it is AB positive. Then it is AB positive. Okay, positive can give blood to negative group person. Acha, when a positive blood group person will give blood to the negative blood group person, then these RH antigens will create an immune response and blood will start to break. That is the reason why a positive blood group person cannot give blood to the negative blood group person. Is it clear? Did you understand the reason? If I am positive and somebody is negative blood group person, if I try to donate blood, my blood, suppose I am A positive and I am donating to a person whose blood group is A negative. Understood. So what will happen when I will be donating? What I thought, A blood group, chalo donate karte hain. Then what will happen? My RH antigens, the RH antigen, because mine is positive, no? My RH antigens, when it will enter into that person, understood, my RBC, when it is transfused into that person, it will create a immune response, it will create a immune response, due to which blood will start breaking. That body, that person's body with a negative blood group will not accept my blood. Is it clear? That is the reason only, as you said, positive can only receive from positive, then negative can receive from only negative, and positive too. See, negative can receive blood. What did I tell? Here can you see? Donor is O negative. Negative can give blood to anyone. My body does not have, my RBC does not have any RH antigens. Okay, so will it create any response? Will it create any response? No. So I become a universal donor. A negative, if I am A negative, I can give blood to A positive, I can give blood to A negative also. Is the point clear? Is the point clear? Understood? Okay. O positive can give blood to O positive, A positive, AB positive, B positive. Understood? But O negative can give blood to both all AB, O positives, AB, O negatives also. Understood, Nana? Okay, so negative blood group. If I have surface antigens, then it will react. No, if I don't have surface antigens, I can give my blood to anyone. Got it? Okay, I am talking only about RH factor. I am talking only about the RH factor. Is it clear? Based on the presence or absence of RH factor, we call it as RH positive and we call it as RH negative. So universal donor becomes O negative and universal recipient becomes O positive. If negatives and positives are not given in the MCQ type of options, then you people are supposed to mention universal donor O, universal recipient AB. Okay. If negatives and positives are also mentioned in the options, then remember universal donor is O negative, universal recipient is AB positive. Got it? Got it, Tana? I have negative blood group. I can donate to anyone because I don't have RH antigens which will go and react over there. If I have positive blood group, obviously my RH antigens will poke in that body, recipient's body. Understood? Yes or no? Shagufta, did you understand? I explained all this again because of you only. Yes? Okay. So this was about blood grouping system. Okay. Then we have another topic, that is blood clotting. Okay. We have come to next level. So we will use the term coagulation. Blood coagulation. Okay. What is it? Blood coagulation. Now when I talk about blood coagulation, okay, there are two mechanisms. There are two mechanisms. The two mechanisms are intrinsic pathway, extrinsic pathway. Matlab, just imagine the wound can be on the outer surface of your body or it can be an internal injury as well, right? It can be internal injury as well. So the two mechanisms, there is a mechanism for outer surface and there is a mechanism for inner surface as well, or the internal injury as well. Okay, yes, Bhagyashri, blood coagulation means clotting of blood. Blood infection, can they donate blood? No. Blood infection. Happily you will transfer the infection to the next person or what? No, no, no. Blood infection person cannot donate blood. When you go for donating blood, no, you will observe they do test that for past if for past few weeks back or past few days back, or months back also you had fever, even fever also, no, they'll not take your blood. There are many criterias. Understood? Okay, now let's see blood coagulation. I will explain the entire blood coagulation in a single flow chart. In a single flow chart. Okay, so let us learn it over here. Okay, now this can be internal injury, two conditions, okay? Internal injury or external tissue injury or external tissue injury. Okay, so in both the cases, hurt heals faster than the outer one. You don't know, no, how much time it is taking to heal internally. It does not mean so, okay, because the process remains the same. It's not so. Got it, Abhishek? Yeah. Now see, internal injury. When there is an internal injury in the blood vessel, there is a rupture of the blood vessel, then it will release something called as thromboplastin. It will release something called as thromboplastin. Thromboplastin. Okay, who will release this thromboplastin? This thromboplastin is released by platelets. So it is called as platelet thromboplastin. So it is called as platelet thromboplastin. Same is the case when there is external injury. When there is external injury, it will again release thromboplastin. It will again release thromboplastin. This is tissue thromboplastin. What is it? This is tissue thromboplastin. Shagufta, let me. Okay, then you will understand the term. So now internal injury may in platelet thromboplastin was released. Even if it is external injury, thromboplastin is released. Now these thromboplastins undergo a series of reactions, which will result ultimately in the formation of something called as thrombokinase, which will result in thrombokinase. The other name for thrombokinase is prothrombinase. Prothrombinase. And one more name is there, that is thromboplastin. Thromboplastin activator, or you can say directly enzyme activator. Why too? It is nothing but an enzyme activator. Okay, got it? So remember this internal injury ho ya external injury ho, both of them are releasing thromboplastin. This thromboplastin undergoes a series of reaction to produce something called as thrombokinase. Now this thrombokinase is present in the blood. What will it do? Remember a point that in our blood there are multiple factors, blood clotting factors, but all of them are inactive in condition. Whenever there is a need, or whenever there is an injury, or whenever there is a rupture of the blood vessel, rupture of the tissue, then these inactive clotting factors will transform into the active clotting factor. Okay, one of that inactive clotting factor is prothrombin. So this prothrombin, which is actually inactive in condition, which is actually inactive in condition in the presence of in the presence of thrombokinase, this one nana, in the presence of thrombokinase, whenever we have the term ase in the ending, remember it is an enzyme. Okay, it in the presence of thrombokinase gets converted into thrombin, gets converted into thrombin. Thrombin is an active form. Thrombin is an active form. Now, while conversion of prothrombin into thrombin, it requires an enzyme, but that enzyme only is not sufficient. It also requires help of the calcium ions. It also requires the help of the calcium ions. Now, the other one is, now what is produced? Thrombin. What is produced? Thrombin. Next, what happens? In the blood, there is another inactive factor which is called as fibrinogen, which is called as fibrinogen. This fibrinogen, this fibrinogen, again in the presence of thrombin, here thrombin was produced, no, that same thrombin is utilized over here. In the presence of the thrombin, gets converted into fibrin monomers, gets converted into fibrin monomers. Again, point to be noted, fibrinogen is inactive in condition which transforms into active fibrin, which transforms into active fibrin in the presence of thrombin, and it also requires calcium ions in the presence of thrombin, and it also requires calcium ions. Inactive means if they are active in condition, blood will clot inside the blood vessels. So they are sleeping. Just think they are sleeping. Whenever required, matlab whenever there is a need, whenever there is an injury, they will get activated, because if they don't get activated, there will be blood loss from the injury. So they are converted into the active forms. Now, this fibrinogen is a complex structure which is transformed into fibrin monomers, which is transformed into fibrin monomers. Now let me show you this. Okay, this is a blood vessel which is having an injury, which is having an injury. Got it? Now this fibrin monomers, ऐसे monomer मतलब single thread like structures. Monomers मतलब single thread like structures. These fibrin monomers will form a mesh-like structure, will form a mesh-like structure at the site of injury. Okay, at the site of injury. Now, what was actually happening inside? There were certain RBCs, platelets, all these were trying to escape. All of them were trying to escape, right? Or you can say these are blood cells. Okay, were trying to escape, but there was a mesh-like structure which was formed on the site of injury, due to which all the blood cells got trapped in that network-like structure, which results in the formation of clot, which results in the formation of clot. Is it clear, Nana? Is it clear the entire mechanism? Yes. Okay. So whether it be internal injury or external injury. Internal injury, this will be called as intrinsic pathway. This will be called as intrinsic pathway. Okay. And external injury, this will be called as extrinsic extrinsic pathway. Got it? Okay, point to be remembered here. Even while the formation of internal injury or external injury, there is a requirement of formation of thrombokinase. This also requires calcium ions and it also requires vitamin K. So, if you are asked what are the important components during the clotting of blood, it is calcium ions and vitamin K, which is released from the liver, which is released from the liver. Is it clear, Nana? Is it clear? Yes. Did you understand blood coagulation? Yeah? Okay. So this was about blood coagulation. So we have completed everything about blood. Next, I want to tell you about blood vessels because in the component of blood or in the components of circulatory system, we learnt about the blood, then we also learnt about the heart. Something was left out, which was blood vessels, which was blood vessels. Okay, so there are two types of blood vessels. What are the two types? Arteries, arteries and veins. Arteries and veins. Let us sum up the points. Arteries carry oxygenated blood, but there is an exception. Except pulmonary artery. Except pulmonary artery. Okay, it is bright red in color. It is bright red in color and it is present deep in the skin. It is present deep in the skin. Coming to the wall of the arteries, it is having thick elastic walls. It is having thick elastic walls and it is non-valvular. Why is it non-valvular? Because valves are absent. It does not require the closing of or it does not require to prevent the backflow of the blood. Now let us see the same for pulmonary, for veins. Okay, obviously tell me the contrasting points. It carries deoxygenated blood. It carries deoxygenated blood except pulmonary vein. Except pulmonary vein. Okay. It is deep or you can say it is bluish red in color. Bluish red in color and it is present in the superficial layers of skin. It is present in the superficial layers of skin. Now when you see your skin, you can see these blue colored lines, right? Those blue colored lines are nothing but blood vessels is fine. But which blood vessels? Veins. Because veins are present in the superficial layers of your body. Whereas arteries are present deep inside the body. Understood? So it is present in the superficial layers of the skin. Coming to it is having thin walls and less elastic. It is having thin walls and less elastic. Veins are valvular. Veins are valvular. They require valves to prevent the backflow of the blood. Ma'am, all the nerves that we observe are vein. Nerves are something different, veins are something different. How are you combining both of them, Akshaya? Whatever these lines that you are observing, no, those are not nerves. Naral kanpinchesnai, naral kagavi, avi veins. Understood? Naralu means nerves. Understood? Okay. Now, one important thing that I would like to mention over here, thickest, or you can say largest, largest artery, largest artery is aorta. Largest artery is aorta. Okay, and same let us mention over here also, largest vein. I mentioned it in the class. Largest vein is vena cava. Largest vein is vena cava. Okay, and one more thing I would like to tell you, the reason over here it is having thick elastic walls, no, arteries are having thick elastic walls. Why are they having thick elastic walls? Because blood flows with high pressure, because blood flows with high pressure. Is it clear? Is it clear? Yes. Caval vein, vena cava, same thing, Shagufta. Caval vein, vena cava, same thing. Okay. One more thing I would like to tell over here. Veins may, I said no, they are carrying deoxygenated blood except pulmonary vein. Pulmonary vein carries most or most rich oxygen in blood. From lungs it comes, no? So it is carrying the mostly rich oxygenated blood than all the other veins. Okay, than all the other arteries or than all the other blood vessels. Is it clear? Is the blood vessel part clear? Yes? Okay. Last but not the least, the topic is lymph. The topic is lymph. Okay, in our body, like we people are having a proper blood circulatory system, we also have a lymphatic system. Okay, point to be noted, lymph is nothing but a part of blood. It is not separate fluid, matlab it is not completely something different, but it is a fluid composition which is formed from the blood. Its composition is very similar like plasma. Its composition is very similar like plasma. I want to show you something. Let's say this is artery. Okay. Then let's say these are veins. Mhm. Okay. So what are these? These are veins. What are these? These are arteries. Arteries. Okay, smaller ones are called as capillaries. Smaller ones are called as capillaries. Now see carefully, I'm labeling it with yellow. Okay, so when the blood is flowing through these blood vessels, okay, it has come into the arteriolar end. It has come into the arteriolar end. Okay, and it is slowly moving into these capillaries. It is slowly moving into these capillaries. Now when it is moving into the capillaries, there is high pressure on the blood. Okay, now they just think that thick pipe may say flow will be very easy. Now you make the pipe very thin, then what will happen? Pressure will increase. So because of high pressure, some of the parts of plasma or some of the components of the blood starts moving into the space, start moving into the space. This space is what is called as the interstitial space. interstitial space, and the fluid which is present in this is what is called as the interstitial fluid. Interstitial fluid, okay, or it is also called as extracellular fluid, or it is also called as extracellular fluid. Okay, now in this interstitial space we are having certain tissues, we are having certain tissues. Okay, so whatever components are coming out from this arteries because of the arteriolar pressure will be utilized by the tissues, will be utilized by the tissues. Okay, to some extent, to some extent. Matlab, and when it is utilized, again whatever is the waste component will again start coming out, will again start coming out. That waste component will start entering into the venular end, will start entering into the venular end and flow into the veins, and flow into the veins. Now there is a tricky thing which happens in the middle. Understood? In between these arteries there are these blunt, these blunt capillaries which are nothing but lymph capillaries, which are nothing but lymph capillaries, which are nothing but lymph capillaries. Now, after the exchange, Nana, I told you, na, some components of arteries are moving out. Okay, some components of the blood because of high pressure are moving out into the interstitial space. That is what is called as interstitial fluid or tissue fluid or extracellular fluid. Okay, some of the components are utilized by it now. Now some of the components are utilized by the tissues which are present in the ECF. That tissues will utilize and give out the waste. Obviously waste will be produced, that will give out the waste. Okay, now point to be remembered, in ECF, I'm talking about the ECF. Okay, in ECF 85% of ECF enter venular ends, enter venular ends, and the remaining 15% enter lymph capillaries, enter lymph capillaries, and when that ECF enters into lymph capillaries, then it is what is called as the lymph. ECF, extracellular fluid, extracellular, out of the cell, extracellular fluid. 85% of the ECF, extracellular fluid. 85% of the ECF will again enter into the venular end, but the remaining 15% which is there, that is what is actually entering into these blue colored lymph capillaries. Okay, and when the ECF enter into lymph capillaries, it is named as lymph. It is named as lymph. Now, what exactly is the composition? What exactly is the composition of lymph? Composition of lymph. Okay, so matlab composition of lymph means what are the things which are coming out? It is number one, small sized proteins, small sized proteins, oxygen, nutrients, oxygen, nutrients, hormones, hormones, electrolytes, electrolytes, etc. Okay, these components come out from the arteriolar end. These components come out from the arteriolar end, which will enter into the lymph, which will enter into the lymph. Now, this is the composition of lymph, right? Now, coming to the function. This was point number one. Next one is function of lymph. Okay, so when I talk about the function, there are three functions. It is transporting fats, lacteal, okay, transport lymphocytes, transport lymphocytes. What is the function of this lymphocytes in the composition of blood? We learned lymphocytes produce antibodies. Lymphocytes produce antibodies for immunity. For immunity. Okay, this is what is the function of lymph. Okay, now if you see that it is having oxygen came out, but oxygen is present in more quantity. Oxygen is present more in quantity, sorry, oxygen is present less in quantity and CO2 is more in quantity. Its composition is similar to plasma but lack large sized proteins. Okay, so nothing, Nana. Lymph is nothing but a part of what is after small size that is not visible properly. Where is it? Small sized proteins, Nana. PTNS is short form of proteins. Okay, so lymph is nothing but a component of blood which is usually coming out and entering into the lymph capillaries, and which is actually helping for the transportation of fats and transportation of lymphocytes. Lymphocytes are producing antibodies for the purpose of immunity, for the purpose of immunity. This is what is about lymph. Point to be remembered, lymph composition is very similar to that of plasma. Okay, but the only thing is plasma mein very large size proteins are there. But as I told you, blood vessel is not permeable to large size protein. It is permeable to only small size protein. So only small size proteins will be moving into the interstitial space. That is the reason lymph has very small sized proteins. Is it clear, Nana? Yes? Yes or no? Okay, I will be sharing you, Zavia Sabine, today's facts. Okay, there is no time for fact of the day, but let me tell you one thing. Today there will be a worksheet which will be sent from the bio end. Understood? Okay, it will have 50 questions. How many questions? 50 questions. You people are supposed to solve it. Okay. On Monday, we will be discussing each and every question. Don't copy it from any source. Try to solve it on your own. Prepare the notes. See the previous, because you said you are having previous videos. So go through the previous videos. You will get the notes there itself and then solve the homework. Understood? 50 questions. Just see whatever questions you people can solve. Just solve them. We will be solving them again on Monday. I will be clarifying your doubts. Is it clear? Akshaya, this slide, this slide, some components come out of the arteriolar end used by the tissue present in the space, and then some of the components will be entering into venular end. Whatever components are coming out, 85% will enter back into the venular end, but only 15% will be entering into the lymph capillary. Whatever 15% of ECF enters into lymph capillary is what is called as lymph. Now got it, Akshaya? Tomorrow there is no class. Tomorrow is a Sunday, so it's a fun day. So I don't want to trouble out you people. You want class tomorrow also? Still, I will not take. It's a fun day for me. Okay? Thank you, students. Please go through the notes and please do the homework, because on Monday I will be clarifying all your doubts. We'll be solving all the 50 questions again. Let me check who can solve maximum number of questions. Notes will be sent, Shagufta. Wait. Wait till the notes is sent. Okay? Thank you, students. Have a great day.